visto in piedi che comunque si vede. Sì, il computer.
Il secondo talk non è già seduto. Scusami, il secondo, quello che deve fare il secondo intervento.
Sì.
Ma lui può stare come lei c'è prima Raffaella.
Sei seduto dove? A presentare? Ah no, diglielo. Sì, sì. Lo speaker però non ha. Vado secondo sono una cosa che dov'è lo speaker? Lo speaker è qua. Almeno perché vedo che non c'è quello per. Non c'è la wasiera. Non c'è quello per arreggere il microfono, quindi gli do l'archetto. Sì, se è possibile sì. Ok, allora va usato. Ok, vabbè, io tanto lo accendo e glielo metto lì, tanto è già.
Hello.
good?
Test, test. I need an adapter. Hmm?
Good? Nice. So, as we asked also in the opening, who is here for the first time? Oh, wow. So you're here for a treat. And sorry, we'll come pretty full, if you can. Thank you very much. And yes?
By asking here, you mean here in Italy or on PyCon?
Oh, that's a good point. Let's do the statistics. So who's, well, if you have been in PyCon Italy, probably you're already been in Italy. So who of you has been in Italy but not in PyCon Italy? Okay, so why you were here not for the conference? Tourism, family? Nice, nice. And, sorry. And yeah, so just to remain a reminder for all of you, usually, just for as a reminder, the question can be go from Slido. So this is the room Panino. Feel free to go to Slido and ask your question. I can anticipate that this session will be interactive, so we'll not have a question at the end, but during the session directly. So I do really much like the interaction between the public, and especially if we have a few questions, you can also ask anonymously from Slido. I can be your voice, or eventually you'll stick around also during the rest of the conference, right? So you can check also a bit later. So, wait. Sorry? So you can find it in every talk in the schedule. You can click in every talk and they go directly to the Slido. You also have received an email with all the links, but especially the faster way is to go to your favorite talk and click there so you're sure. Once you open it, I suggest you to bookmark your tab with Slido and then just change the room for the Q&A. Okay? So now we are ready for our first talk of this great track in Panino. Here with us there is Adrian. He's a great maintainer for scikit-learn and co-founder of Probable. And today he's going to talk about dynamically generated methods with node-generated signature. So if you're intrigued by the questions, intrigued by the topic, stay tuned. And Adrian, the floor is yours. Thank you.
Thank you very much. So this talk is motivated by the work we did in scikit-learn. It is now released. Some of the features that you would use pretty much the code that we're going to present today. A little bit about me. After I did my academic work in cancer diagnostics with machine learning, I did some machine learning consulting. Then I found my way into open source. And these days with a bunch of other great people, we just do open source at Probable. In order to understand this talk better, there are a few prerequisites. First, to know that functions can have variable number of positional arguments, like this one, or a variable number of keyword arguments. When you define your function, this is how you say, I want to accept those. In Python, there are things like setAttr, getAttr, hasAttr. Those things, if you're familiar with them, it would help you. There are dunder methods that do magic in Python. Probably the one that you're used to use the most is init, the constructor of the class, but there's a bunch of other ones, and a lot of them do a lot of good magic. Inheritance, we're going to use a little bit of that. We're going to do a little bit of type annotation, use optional, and that in Python, if you get help on anything, it tries to show you whatever it knows about that object. So, with that aside, what is the motivation to this talk? This is the motivation. In scikit-learn, if you have a transformer that, any class that inherits from base estimator, you might have a transform function, you have this method, and it accepts something other than x and y. Here it's shift. Then it should, an instance of that class should have this method. That is the requirement. We did not define it here, but it is somehow magically defined. And it returns a really nice docstring with all the parameters, and it says like each parameter what it does, what it accepts, what's the name, all of that. And then I can also use it. But if I pass it something other than that thing, shift, that existed in the signature, it tells me that it does not accept that. This is what we want to achieve today. And also, if my method does not have anything other than x and y, that method should not exist. So, let's see how we can do that. And we also had a bunch of requirements in implementing that. We did not want any of the estimators, especially the third-party estimators, to implement any change. It should just work out of the box magically. It should be a little bit more helpful than having a very generic signature, and it should have a really nice doc string. The way we do that is that we are going to inspect the methods defined by the child class with inspect. Then we are going to use inspect.signature to create a custom signature. We use a descriptor returning a function to be set as the generated functions that we're going to attach to those classes. And we use init subclass in the parent class to customize the child class. And now we go one by one through all of these things that when I started working on this topic, I had no idea what they are. So inspect. Start maybe with the easier ones. Here I have a function. It has a bunch of inputs. It has a type hint int, a variable number of arguments here, a keyword argument, and a variable number of keyword arguments. Another one similar as a method of this class. Also, if you have any questions, as Stefania said, please raise your hand. So we can ask inspect, is f a function? Yeah. Is aid.g a function? Any guesses? Yeah, no. Because it's a method. But a.g without the instance, it is a function. We're going to look at exactly the signature and what the difference is between them. We can get inspect.signature to see what this function should probably look like, and it gives us something which is pretty informative. It tells us what the function looks like, but we can also do more. Here, what we do is the parameters attribute of the output of this signature is a dictionary that returns the parameter name and the information about the parameter. And what we're going to print is the kind of it, what is the default, if there is any default, and if there are any type annotations. And it gives us, it says there's an A, it's positional or keyword, there's a variable positional argument there, B is keyword only, and we have a var keyword arguments here. And if there is any default, it also shows us here. We can do that same thing with a.g. Note that here it's without the instance. And it returns us everything plus self. So you could call a.g and then also pass a self to it, which wouldn't be self, but it would be an instance of a compatible class. It would work. Or if you get that from the instance, then self is automatically set for you, and you do not pass it. So here you don't see the self here. That's pretty much the difference, kind of. To read more about it, in the inspect module, it's great documentation there. So that first component, now we have it. Any questions? Good. Now let's talk about functions returning functions. I want to have a very simple function. It just adds 5 to the input. Easy. We all know how to implement that. But here I want to have a function that creates functions that I want to tell it how many I want to add to the input. Here I pass the value to this one. This one takes only x. And here I have, because of the scope, I have access to this value. And then I return f. And here I can have a variable and I say, hey, create adder 5, and then I can use it as a callable. It's a function. I can do the same thing with a lambda expression. So we can also do that in Python. That easy? Cool. Now, let's talk about a function's outfit. By outfit, I mean things that you get when you try to call help on it. In this case, we have a variable number of positional arguments. We add them up. And we have a tiny docstring here. What happens if we get the help? It just shows us the signature and the docstring and the name of the function here. We can call it. We get the addition. $duck returns the docstring. $name returns the name of the function. And we already know that we can get the signature here. So now, let's try to change that outfit. We are going to change the name of the function. Why not? We can. And then we have a list of parameters. The parameters, each one is an inspect.parameter, and then we say this is the name, this is the type of it. Note that here we are lying. This is like you can't pass a as a keyword argument here, but we say it's positional or keyword. The point is that what you said here is not the source of truth. We set a default for it. Again, we're lying. There's no default there, really. And we say it's an optional float. We say we have 2 arguments here. And the signature of f, we set it as to be an instance of this signature that has these parameters. And the return annotation is also float. It returns float. Again, all of that is a lie, but doesn't matter. And we set a nice docstring here. So what we're doing is we're setting the name, the doc, and the signature of the function. After we do that, when we get help, it says it's adder, it has this signature, and it does that. And if we try to get the signature of f, it also tells us that it takes only 2 arguments. But we can still call it with 3 arguments. So invoking a function or a method does not check the signature of the method if you have assigned it something other than what it actually is. The signature is used only if you want to inspect it, not when you want to call it. Any questions? This is a lot, I know. Don't be shy. Cool. The Python signature object was in PEP 362. Feel free to have a read there. It is a nice read. For me, I had to read it a few times before I was able to write this code. So don't be scared if you don't get it the first time. Now, descriptors. We're going to have another talk right after this one, a deep dive into descriptors. This is just a very, very short version of that. We're going to use what we need for the rest of it. A descriptor is a class attribute, not an instance attribute, that implements $get. That's the definition. And the way it works is when you try to access an attribute in Python, if that attribute implements $get, Python will call $get for you, and it will return that return value instead of returning whatever you had here. So here I have a class. It's a normal class. It can be anything as long as it implements this $get. In the constructor, I pass it a name. In get, I return a string using that name. Here, also, like in each step, I'm printing something. Then I print here that, yeah, I define that. Then I go through the definition of the class. I say this class attribute is an instance of this class. Then print something and create an instance and get pet. Now, the question is what happens if you run this? Like, in which order do the prints go out? Well, as we are defining, as we are coming down, this code is not run, so we won't get any prints. That's kind of clear. Then we print this one. Easy. Then we have the definition of the class. Then we print something, and then we create the instance. Now, the question is, when does this come out? Here or here? Yeah. When you define it, it is already instantiated. So if I run that, I defined it, then the descriptor in it already is run here, then I get here, I construct my class, and then if you're working in a library, what was confusing for me was a lot of that is run in import time. Every code that you have here, these subclass which is run when you try to inherit from the parent. So we want this class, but we just don't want to write this code or anything related to that here. What does init subclass do? It takes the class type, and then you can do whatever you want with that class type, and then you can inherit from it. To see what happens here is that, let's see. This print prints the child class, so you definitely have access to the child class that is trying to inherit from you. And then we set things here, and the instance is created after the class is defined. Now we have all the components. What we do is that in parent, we can check the signatures of the method of the child. Well, we have access to this child class. We can get that method and check if it's a function, and if it's a function, gets its signature. If we run that, we see that in the parent class, we have the signature of the child's fit. And this was one of the key components that we needed. In the parent class, we wanted to check the signature of the child class's method. Based on that, we wanted to define some functions, and we are going to attach to the child class through the descriptors. And this is how we do that. We check if the child class has a fit, and if it's a function, sure, we're good. We get the signature of that method, and then we check the parameters. We ignore self, x, y, because we know those ones are the standard. We only care about whatever else is there. And then for all of them, we set, if something exists, then we set an attribute. The attribute would be to the class, this one that is given to us here. This would be the name of it. And then this would be the descriptor. Which parameters? These parameters that I just got here. And then I call my parents init subclass, if there is any there. And now I can just define my child class and inherit from my parent, and this magically exists. And if I get its help, it's a nice help. The init subclass is also another PEP. You can read through that here. It's nice. So what we did, we used inspect to see what's happening around our methods. We used signature to create a custom signature. We changed the doc string. We set the name, and we use init subclass to customize the child classes.
Actually, a question for a clarification.
Sure.
Can you explain again why all that was needed with some example of the code that enables you to write now compared to before? And if you want to read it a second. And
can you explain again why?
Feel free to raise your hand if it's here or if it's online. We can.
With some examples of the code that it enables you to write now compared to before. I'm not sure.
I think it was the last example.
The last example,
yeah,
or the first example?
No, it was the very right now.
Maybe this one.
Yes. Thank you.
So what we wanted to do, let's go back to the original motivation. What we wanted to do. We want to have a custom estimator here, a custom class that inherits from this base estimator, some random parent class. We have a few predefined methods in our API. One of them transform, one of them fit, one of them predict. And based on the signature of them, here, for example, shift is on top of what we usually expect. We want if that exists, if this shift exists or anything else, we want a set transform request to exist as a method that accepts shift as input and sets something on the class, on the instance. This is what we wanted to do. And we did not want to write this one. This automatically got generated. Yes? Yes, I repeat the question.
Thank you.
The question is if transform name is completely arbitrary. Yes, it is arbitrary, but it is also hard-coded somewhere in the code. If I go down here in our example code, we are doing that for fit. So we are assuming that fit exists, and if it does, then we do something based on the signature of fit. In scikit-learn, in reality, what we do, we have a for loop for fit, transform, predict, fit, predict, like all of those. And then, in order to do that in the parent class, we need to know what's happening in the child class. Here, I see if the child class has a fit method. If it does, I get its signature. And once I have its signature, I can make decisions based on that signature, which I'm doing here. And that's what I meant by all I need. Yes?
So you showed us some black magic and the motivation for it. And can you tell us something about, because black magic can be costly to maintain. So how do you go about deciding when to use black magic or not, especially in a very well used scikit-learn? And if there were cases in which you decided not to use black magic?
It's a very good question. Each community has its own principles. So this is not something that you can apply in every group. In scikit-learn, it is very important for us for the project to be maintainable and also for the project to be accessible to new maintainers, which means we try to avoid using black magic as much as we can, to the point that we have resisted a lot historically also to have a lot of decorators. Decorators are great. You can do a lot of really cool things with them, but we try not to do that because it takes a while before. There's a big gap between when you start learning Python, you go to a boot camp, to the point where you know what decorators do. And if you use a lot of that stuff, then all the people who are still in this gap cannot contribute to your project. Same here. We definitely did not want to do this black magic. But not doing it would have the cost that every developer who has a custom estimator outside scikit-learn, inside scikit-learn, sure, we're like, we can change everything we need, but outside, then they would have to add these methods, and we didn't want them to go through that burden. So this was the balance which made us decide in favor of this black magic.
Thank you. We have another question for remote. I'll let you read directly if you want. It could be a follow-up of the previous one.
What if the request or fit method is a class method? Should it work the same? Yes, as long as you can get it here. If anything, here I am accessing through the class, not the instance. And if it's a class method, it's a class method. You can still get its signature and make decisions based on that. So that doesn't change anything in principle. Yes.
How do you choose to document this? Is there a guide for users and a separate guide for developers, or do you mix both aspects?
I love these questions. So we have a very long doc string at the beginning of the file that implements all of this, explaining what's happening in this file. That is for the maintainers. We have another user guide, which is for the end users of scikit-learn, explaining what these methods do, how to do metadata routing, which does not even mention how they are generated. The end user does not care, should not care. Then we have another one, which is for the third-party developers, which explains how third-party developers could implement their own estimators with regard to whenever it's related to these methods. And then the combination of the three is enough to confuse everybody. I certainly have mentored people in getting into this part of the maintenance. and they do not find it easy, and I do not blame them. It is really, really hard. There are no easy answers to that.
We have another question in here. So, more a general question. You're showing the code for Jupyter Notebook. Perhaps someone is not comfortable with that, was asking if that works also in any IDE or if the process will be different. And
Yeah, no,
if you want to.
The only thing that changes, I just like to have a live demo here, but obviously in scikit-learn, all of this is done in IDEs. It's published in a library. The only difference here would be that your module name here wouldn't be main, the one that I'm highlighting here. And it would be a part of your module. That, like, none of the code changes in that regard.
Yeah, perfect.
I have a related question. Do you do anything for language servers like Pylance to recognize your method, or you don't care?
Haven't done anything. So Pylance, I think Pylance inspects the live objects. So there we are okay, pretty sure. But what would not be okay is type checkers like MyPy.
Yeah, that's what I want. Yeah.
For that, what we have in scikit-learn is all type checkers, what they do is that they don't run any code, but they parse the code. They go through the abstract syntax tree and then they see what they can infer. They infer what they see. And for that, there's also a special variable name. You can say if you're a type checker, and then you can some special code in your code that is only true for the type checkers, and it's never run. What we do in scikit-learn is that we have that, and we define hard-coded all of these methods with a completely generic input, like keyword arguments and args, for the type checkers to know that these methods exist and accept everything. But they cannot check if the input is actually the right type or if it's the right input that is accepted or not. That they cannot have. What we give MyPy is that, hey, these methods exist, so that at least it doesn't complain.
So just make sure, I'm not sure if I understood. Does it work, for example, in VS Code, the autocomplete feature, does it work with
So
these?
the autocomplete uses Pylance, or language server. The language servers inspect the live objects. So for them it works. Like there you're fine. It's the type checkers which is a little bit more tricky.
Right.
I'm 90% sure about the Pylance thingy though. Would need to check if it actually inspects the live object or no.
Okay, thank you.
Thank you. The question was a similar question, so already answered. So great applause to Adrian. Well, can you tell us where we can contact in terms of other further questions?
Well, my name on LinkedIn, or here are my talks on my GitHub, and wherever you can contact me.
Perfect. Thank you very much. The next talk will start in 10 minutes, so feel free to change or stay in the room. Thank you. So we have here with us Rodrigo Girao Serrao, that is a teacher, educator, is a huge fan of math games, as I am as well. So we'll see more about that, but especially for today, we'll see the scriptures made easy. So a great continuation for this track. Thank you so much. A great applause for Rodrigo. The stage is yours. Thank you.
Descriptors are so powerful, I can use them to control you, and yet they're so simple, I'm going to explain how they work in the next 40 minutes. So thank you for the introduction. My name is Rodrigo, and I wanted to make sure that everyone here knows a little bit of Python at least, by show of hands. Now, please keep them for a second, and take a look around to see how many hands are up. Okay, excellent. Now, how many people have used descriptors before? Now take a look around. There's fewer hands up, right? Just bear that in mind. Now let's do some live coding. Is this readable from the back? Can everyone read this? Okay.
Is a so and so in the back?
There's a what?
A so and so in the back, so very slightly bigger. Okay.
Yeah, can we dim the lights, please? Is it possible to dim the lights? Okay, so while we check for that, let's see if we can zoom in a bit. It's not the same thing, but it might help a bit. Okay. So the thing is, I want to explain how descriptors work. And to do that, I'll start by defining a class person. And I'll define an init method that has nothing to do with descriptors. And I'm going to say that the person is going to be initialized with its first name and its last name. Yeah? Feel free to, if something doesn't make sense, feel free to interrupt me. It's a small enough room that we can interact a bit. And so what I'll do here is I'll save my first name for later. I'll save my last name for later. And I'll also, perfect, it's better. Excellent. And now I'll also save my full name, which is going to be my first and my last. Is everyone okay with this piece of code? It shouldn't surprise anyone. Now what I'll do is I'll run this piece of code. And now what I have here is a class person. Yeah? And I'll create a John Smith. Just a random dude. I've got John there. Now, what's the name of John? If I press enter, what do I get? Okay, excellent. Now, let's say that John Smith is no longer Smith, but rather Serrão, which is my last name. If I type john.name, what do I get? Okay, which is wrong. This is a problem. And typically the way we solve this in Python is by using a property. It's the property decorator. The issue here is name, the attribute name, has dependencies on two other attributes, and yet we only compute it once. And so when the first and last attributes change, name becomes outdated. And the way we typically do this in Python is, or the way we fix this is by creating a name method. Thank you. The applause is for me, I'm sure. We create a name method, and instead of assigning something, we return the value we care about. Now in here I need to access my attributes. And this is currently a method, so what we do is we add the property built-in that turns the method into an attribute, right? So let's run this again. I've got my person, I have a John Smith, and if I do john.name, I get John Smith. And if I change the last name of John to Serrão, and if I do john.name, what do I get now? John's, yeah, so it's not, yeah, exactly. So the pronunciation is difficult, but we all agree that it's not John Smith. Right. No, but good. It's not a, yeah, okay. We can talk later if you want to get my name right. So what the key thing here, the thing that I think you pretty much already understand, is that this looks like an attribute, from the point of view of the user, but it's actually defined as a method. So property turns methods into attributes. Okay, and if you're comfortable with this, there's no way you won't be comfortable with what I'm about to show. It's no way. So let me put this on the right. Let's create a new file. Let's call it, naming is hard. Let's call it desks2. Sure, and now let's put this on the right. Split right. And now what I want to do is write a descriptor on the left that does the same thing as what's on the right, because we will see that they're actually similar. And so this side by side will help us understand how things work. Is this still readable? I just decreased the font size. Okay, brilliant. So what's a descriptor? Well, a descriptor is an object. Thank you. I'm glad you're paying attention. Exactly. So a descriptor is an object, but that's not saying much because everything in Python is an object. So what's special about descriptors that makes them descriptors? If you were here before, Adrian said that there's a specific method that we want to define. So a descriptor is going to be a class that I'm going to define on the left that is going to have a very specifically named method that is going to mimic this behavior of the property on the right. So let's call this the name descriptor so that we all agree that it is a descriptor, even though I haven't done anything yet. So the implementation is yet to be seen, and the way it's used, the way descriptors are used is as class attributes. So in my class person, if I want name to make use, if I want the attribute name to make use of a descriptor, I need to define it at the class level, and I say name equals, and then I make use of the descriptor by creating it, by instantiating it. And now the question really is, what do I need to replace the ellipses with so that the code on the left behaves in the same way? So this is the question. And the answer turns out to be, if I define this get method with the double underscores on the left and on the right, then I will have a descriptor. And what does this weirdly named method does? This method is responsible for getting the value of an attribute. And so the descriptor will also turn methods into attributes. Or if you look at it the other way, you can use something as an attribute and it will run a method for you. So you have more power to do things that you need, because if you're running a method, you can run whatever code you like. So it allows you to do dynamic things when accessing an attribute. And so what does this method receive? It's a regular method, so self goes first, then, and this is where the fun begins, then we do object. And this object is going to be a person. So this is the thing that has a name. John Smith has a name, and so when I call the name of John Smith will end up here in the object parameter. And then there's a third one, which is the object type. And we will see why this matters later. But for now, it doesn't matter. And so now what do we do if object is a person, and maybe I should actually call it person. So if object is the person that I care about, how do I build the name? Well, I just access first and last and put them together as before. So I can even copy this. Because this is what, I don't know about you, I'm a great programmer because I'm great at copying and pasting. It's what I do best. And that's it. I'm returning. Is anyone surprised by the f string? Okay, excellent. So then, this code implements a descriptor. It's not a very interesting one, and please, I'm not saying that the descriptor on the left is better than the property on the right. I'm not saying that. I'm just making the comparison so that we understand how descriptors work, because this is preferred, the right one. But the left one does the same thing, and I'll prove it to you by running the code. So let's get out of here. Let's do this. Let's run desks2, because that's where the descriptor is. By the way, the -i lets you run a script, and by the end of it, you get an interpreter session with everything that was defined, in case you didn't know, so quite useful. So you can see the name descriptor, for example, is in here. It's defined. And let's create a John Smith. Copy-pasting, scrolling up the history, more or less the same thing, right? And so John.name, what do I get if I press enter? I get John Smith. And this is where the fun stuff happens, because this looks like an attribute from the user point of view, but what's going to happen actually is I'm going to go access this. There's nothing specifically defined in this instance, so we're going to look for name in the class. And the class person has a name. Oh, it's that name descriptor object. Oh, but wait. This name descriptor object has the method get. And so Python will call method get for us. It will put this John here inside the person, and then I get John Smith. Is everyone comfortable with this? Okay, then it should come as no surprise that if I update the last name to be Serrão again, Serrão, exactly, that was good. Then, if I check the name, what do I get? I get John Serrão, which is an odd name, but at least it's correct. It agrees, it matches with the self.last. Is everyone comfortable with this? Excellent. Yes?
Thank you. Sorry for the English. I don't understand how the attributes from person is passed to named descriptor.
Okay, excellent question. So how do I get access to these first and last thingies, right? Excellent. So if I go ahead and if I print, say, I'm inside get. I don't know if you do advanced. I do print debugging most of the time. I only know how to copy and paste. I don't know how to use a proper debugger. And now what I'll do here is I'll print person, and I'll just print person. That's going to be enough. So if I print these two things, I'm going to go ahead and I'm going to exit the file, run it again. I'll create my John Smith. Notice how nothing was printed because I didn't access my descriptor. And now if I do, just posing for the picture, sorry. And now if I do john.name, again, this is where the fun stuff happens. This looks like an attribute, but how does this actually work? Notice how this is, sorry. This is a dictionary. Do you see the dictionary? Do you see a name in here? Excellent. So the John object, the thing, John, doesn't have a .name. So when I do .name, Python looks for the name in here, it doesn't find it. And so it goes up a level. This was the instance. Now it's going to look in the class. John is a person, and the class has a name. I'm just pointing for people that were watching the stream, I'm sorry. So the name is inside the person. So when I do john.name, I'm going to fetch that name, the name descriptor. The name descriptor is an object. And Python will check behind the scenes. We don't see it, but behind the scenes, Python will see if the name descriptor has a very specific method. A method called __, get __. And because it does, Python will call that method over there at the top. And Python will take this John and put it inside person. Python does it for us. And so when I do this, I get the prints. I get I'm inside get, it's over here. And then when I print the person, I see the print here. And take a look at the ID, it ends with 1465D0, and if I do John, it's the same person, 1465D0, so it's the same object. Excellent. Is it clear for everyone? Brilliant, so let's keep going. So this is a part of a descriptor, but actually descriptors have more things to it than just this. There's more things that can make a descriptor, and so we will take a look at them. And again, we will start by drawing a parallelism, drawing an analogy with the property decorator. Because if I do this, I should really rename this file. This is going to cause so much confusion. Not for you, for me. So this is the properties file, and the other is the descriptors file. This looks like a more reasonable. I'm almost eating my microphone. So this looks more reasonable. So if I run the properties, I have a John again. And if I do John name equals, I don't know, let's change the name to John Serrão. What will happen if I press enter? I get an error. Some people say no. I don't know if they don't know or if they just say, yeah, Rodrigo, that's not going to work. It doesn't work. My attribute And notice how they talk about properties. My attribute doesn't know how to set things. So it's a one-way street for now. I can get things, I can't set things. But property lets you set things as well. So what I'll do is I'll create another method. And so this isn't the usual convention, but just for the sake of clarity, I'll say, let's call this the name setter. And so this is a method that I want to run to update the name, which really means just updating the first and the last. And so if I want to be able to set the name, I need to accept a name. And then let's just say, for the sake of simplicity, that the name will always have a first and a last, so I can just split. And now I set them. Is everyone comfortable with this? Okay. Who said no?
No, I said cool.
I misheard. I have the hearing of I have terrible hearing. So we do this. And the method works, but what we want is we want to make it look like I can set the attribute, because there's an attribute that we can fetch. And we do this by using the setter attribute of the property. So name is a property, we put the setter there. Is everyone comfortable with this dot setter? Brilliant. So then, if I run this, I run it, I create a John Smith, and then if I do john.name equals John Serrão, what happens if I run it? Nothing visible happens. Whoops. What did I... Sorry? No, it's the correct file. I did something stupid. Def name setter. Let's see. It doesn't make sense that this is the... Sorry? It should be exactly name. Okay, so maybe it should. And I'm just doing weird stuff. Okay, great. Okay, so then apparently the name must really match, otherwise the property decorator won't understand that that's supposed to be a setter. But the code, I didn't change the code, I changed the name. And now property is happy about it. So nothing visible happens, but hopefully, now I'm nervous, hopefully the last name changed. Okay, good. Yeah. I was honestly a bit nervous there, but yeah. So what's interesting here? The interesting thing here is, again, I'm going to keep saying the same things over and over again. John.name looks like an attribute. This looks like a regular attribute assignment. And yet, when I do this, notice that this is actually being, there's a dot there, and the dot does something in Python. So I'm looking up the name. Again, same story. John itself doesn't have a dot name. It's the class that has it. And so when I do John.name and I go into the class, exactly. And when I go into the class to check for a name, I will find that method over there, this here, that is tagged with a dot setter. And so Python will know that it has to run it. It has to run that method with this string as the name argument to do the assignment. And so then we just do the assignments in there. And so we can do this, we can do the same thing with a descriptor. Again, I'm not saying it's going to be better, I'm just saying that there's an analogy there. So let's do it. Let's split this to the right, and now let's see if I can change the correct file. Brilliant, so descriptors. Now, who wants to guess, if you already know, please don't reply. Who wants to guess what's the name of the method that I need in the descriptor? So the get gets things, so if I want to set something, what's the name going to be called? The underset, brilliant, exactly. So a descriptor can have a method called underscore underscore set underscore underscore. And again, this is a regular method, so self goes first. And then what do I need? I need the person that I care about, and I need the new name. And then the code is going to be exactly the same. This thing here, the split and the assignments, they're the same. So I can just copy this, and I can just fix this, because it's no longer in self. Again, inside the underset, self is the descriptor. I want to change things in the person, so this is person. At a first glance, is everyone comfortable with the code? You better be, because I just copied things around. So it's the same code. It's the same code. Now, let's do this. And let's run it and see if I broke something or not. Now let's run the correct file. Let's see. I'll create a John Smith, and I will assign the name to John Smith. It's a good sign, at least I didn't get an exception. And now let's see, moment of truth. So I did update the last name. Can everyone, let me delete this. Let me close this. Can everyone kind of see what's going on? You're just liars. There's nothing to be seen. There's nothing to be seen there. So I'll just add a couple of prints to make absolutely sure that everyone sees what's happening. So this is, I didn't mean to offend you, but I just don't like when people say, yeah, everything is fine, and then no, okay. So this is set. By the way, personal tip: when you're exploring Dunder methods, does everyone know the term Dunder methods? You can ask me later if you don't. So when you're exploring these things, adding prints all over really is helpful because it helps you understand when things are being called, because there's just too much stuff happening. And now I'm going to run exactly the same code, so I'm going to create a John, and I'm going to assign a name, and when I press enter, you will see that those prints, the prints inside on lines 8 and 9, those will be triggered. So on the count of 3, 1, 2, 3, there's the prints. Yeah, and this John Serrão here comes from it's person colon common name. So there's the person and then the name. And now if I check, it's obviously still the same, as in still correct. Questions so far? No questions? Excellent. So now let's do an exercise. So I'll create a new file. Let me call it, I don't know, colors. And what I want to do is I want to create a class. And I want to say that my RGB color is going to accept a hexadecimal code. Is everyone comfortable with hexadecimal codes for colors? It's just a representation, right? So for example, let's see, F8, F8, F2, this is a kind of, it's a shade of white. This is a color. And it's hexadecimal because it's digits from 0 to F. So I want to do this. And now what I actually want is to save, obviously, the hexadecimal representation. But I want to be able to say something like, so let's create my red color. And red in hexadecimal is something like RGB, so that's going to be this. This is a very bright shade of red. And I want to be able to do something like print red.r. So I want to be able to get the R component. I want to be able to get the green component. And I want to be able to get the blue component. I want this code to run, I just need to fill in the gaps. And the issue here is the same as the issue with the person, because I have different attributes that depend on each other. And so I need to be careful because I want updates on one of those attributes to reflect on the others. So there's this dependency, and that's why I need dynamic behavior. That's why property is relevant, and that's why descriptors also work here, because they let you do dynamic attribute retrieval and dynamic attribute assignments. So how do we fix this? With a property, I would need to write 3 properties, one for R, one for G, one for B. With descriptors, I can write a single descriptor. And so when I first understood descriptors, the way I thought about them were kind of like property factories. So instead of writing 3 different properties, I'm going to write 1 descriptor to replace them all. So there's, one descriptor to rule them all, right? So that's the original quote. So I'll do my RGB component descriptor. And again, the name ends with descriptor, just so we're clear that that's supposed to be a descriptor. And now, this is where stuff gets fun. If you weren't having fun yet, this is where it should get fun. I want to use 1 descriptor, so 1 class in line 1, to implement 3 different attributes, R, G, and B. So there obviously must be something that lets you distinguish between the descriptor for R, the descriptor for B, and the descriptor for G. Because they're supposed to give different results. But I want to encapsulate all of that behavior inside the descriptor. But surprise, big news, I'll break it to you. That's a regular class. Python code works because this is Python, right? So if this is a regular class, it can have an init method. And if I can have an init method, I can say, for example, I can specify the positions of the hexadecimal code where I can find the appropriate component. So let's just say that I'll accept a position and I'll save it. And then, in my dunderget, which is the method that will run when I access the attributes, I'll be able to do something with this position. So what are the arguments that go in? What are the parameters? Do you still remember? Yeah, so this is going to be a color, and then something. We don't talk about that, at least for now. Now, how do I get the appropriate component inside my descriptor? Well, I need to make use of the position. And so I'll do return color.hex, and let's slice it. So that's going to be, I can't type a lot here because otherwise it's going to go off the screen. So let's do the following. Let's do self.pos. And so this should be p+1, p+3. And now let's turn this into an integer, because why not? 16. Everyone comfortable with this piece of code? One thing that bothers me is that Black doesn't agree with what I wrote, and so Black reformatted it, but then Flake doesn't agree with the spaces here, so I don't know, they just like to fight. And if I run this, will this work? If I run the code, will I get the R, the G, and the B? I won't. Excellent. Why not? Because I haven't used the descriptor yet. Guys, please pay attention. So I still need to use the descriptor. How are descriptors used? You set them as class attributes in the appropriate class. Now, will this work? Okay, the red underlines gave it away. What am I missing? The position. So this is going to be, how did I define this? Yeah, I'm glad you're paying attention. Yeah, it is. So this is actually kind of stupid. But sure, it's going to run, so it's fine, I think. Now, what do we expect as outputs here? So what's supposed to be the output of red.r? Nope, because I'm converting the integer, just for extra confusion. And then these are going to be 0. So if everything goes well, we get that. Okay, we got it. So take a look. Let's, so the output is there. And I reckon the descriptor is more interesting than this. But this is not going to work, right? Of course not. So what I'll do is, I'll put this here. And actually, I won't do anything because I can't. I wanted to show you the code. Everyone comfortable with this? All right, so what have we seen? We've seen that I can use a descriptor for multiple attributes. We've seen that dunderget runs dynamically when we try to access attributes, and dunderset runs dynamically when we try to assign to attributes. Now let's do one thing that's even more general. Which one do I want to do? All right, let's do, I was thinking and I've decided. Let's do a descriptor.
Your question about the approach. Originate question, maybe we should design the classes with method instead of attributes and property, solve lots of issue and cost of extra parentheses. But perhaps it's a matter of the approach that we're following.
I didn't understand the question at all. Can I read it, please?
Yes,
Sorry.
It's anonymous, but if someone wants to work.
I'm going to read it aloud. So maybe we should design the classes with methods instead of attributes properties. Solves a lot of issues at the cost of extra parentheses. Okay, so I would rather we don't go into philosophy because I'm not in a position to discuss it. So assuming as an hypothesis that the Python standard way of doing things is fine, this is how we do it. The discussion of whether we should have getters and setters or not is a whole new discussion. So let's just focus on, let's assume that properties make sense, and thus descriptors make sense. Other questions? I mean, you can ask philosophical questions, but I'll just decline to answer.
Is property implemented using descriptors?
Let's get to there later.
Okay.
That's a good question.
Thank you.
Thank you for your question. So if you didn't hear the question, that's fine, because they're spoiling my talk. So, alrighty, everyone fine with this? Brilliant. So let's do one final thing. In Python, there's another convention. There's this one person, I mean, there's plenty of people I like, but there's one Python educator that says that Python is a language for consenting adults. You can't really prevent anything from happening, but there's certain standards and conventions that we all agree to uphold. So for example, if I were to redefine my class person, but if I were to say something like, do you ever do this? I always do this. I do the two leading, but then I forget the two trailing. And then my code doesn't work and I wonder why. So let's do the same thing, but now I'll write self._first equals first, self._last equals last. Has anyone ever seen this convention of the leading underscore? Right. It's the convention to say this is private, please don't touch these attributes. However, we don't do protected here. That's Java land. So sorry if you have to write Java code. So let's just run this. Let's run the private. It's not even private, because what I can do is I can create a poor John Smith, and I can do John first equals Rodrigo. I'm very self-centered if you haven't realized yet. I can do this, and it works. There's no exception here saying name was protected or private. There's no such thing. So now let's write a descriptor that enforces this, so that it hides this behind a wall. Or rather, let's mimic this behavior. If I do, again, using property, I could do something like def first. And if I do return self.first, what am I actually doing? I'm creating the getter without creating the setter. And therefore, if I try to set, so John.first works. Nope, it doesn't. Yeah, thank you very much. You were paying attention, that's good. You're passing all of the tests. So if I do John Smith, John.first, this works fine. And if I do John.first equals Rodrigo, it doesn't matter the spelling because it doesn't work. So there's an attribute error there. Yeah? Why? Because we didn't define the setter. So let's mimic this behavior with descriptors. And now what I want to do, and that's why I went through all of this trouble, is I want to write one descriptor, so one class, that I can use for all of the attributes in all of the classes that I want to make read-only. So in here, for first, I needed one getter. If I wanted to do it for last, I would need another getter. If I wanted to do it for other classes and other attributes, I would need to define one getter per each. I'm tired just from saying it. Imagine if I had to write it. So what I want to do is one descriptor to rule them all. That's how it goes. One descriptor to rule them all. So we'll do the read-only descriptor. Again, it's not the name that makes it a descriptor, right? We already know that. Now, we need a getter here. And this is where things really get interesting. So I no longer receive a person or a caller, I just receive a random object. And in here I'll receive let's keep avoiding this subject. I receive something else. And now, what do I do there? What do I type there that's going to solve all of my issues? Because if you think about it, it's going to look silly. It's going to look very silly if the way I do this is by saying first equals, if I manage to type it. I don't want to do this. I don't want to have to pass the name of the attribute into the descriptor, because that's just asking for trouble. I will eventually, I'm not saying I might, I'm telling you I will change the name of the attribute and forget to change the call to the descriptor. I'm going to forget that. So I wish Python was smart enough to provide me a way for this to work. So let's just, if we wish really, really hard, then maybe, just maybe, there will be a way to do this. Thank you. And so what we will do now is actually realize that there is a way for this to work, and it's brilliant. There is one extra special method called setName. setName. This is __ setName ___. Now, it has nothing to do with descriptors, so the presence or the absence of this method does not influence whether a class is a descriptor or not. But it's very useful here because what setName will do is, or rather what Python will do with setName is, when a class is defined, when this happens, Python will instantiate read-only, it will assign it, and because this thing here has a setName method, it will call it, and it will say, hey, by the way, this specific class received these specific attributes. And so I get notified, as a descriptor, I can get notified of the class that I was assigned to and the name that I was given. And this is just brilliant because now what I can do is, I can obviously save my own name. It would be ridiculous if people went around and say, what's your name? And I don't know. So we save it for later. And now when we try to access the attribute, what do? We do some dynamic lookups. We will return the get attribute of what? Well, the attribute lives inside object. What's the name of the attribute? Well, it's underscore the name that I was assigned to. So that's going to be underscore, what was it? Self.attername. And that's it. Yes, I'm sweating. Right? Now there's lots of, so let's do the following. Let's do this. I'll comment this out. I know there's a shortcut for it, but I'm too nervous to remember. Please don't judge me. So I'll comment that out, and I will do the following. In setName, I'll print, inside setName, I'll print the CLS and the attername. And if I run the code, I should get 4 prints, because setName will be called twice. Let's actually, yes, I can cut this, so there's less stuff. And I will be called once with the first and once with the last. So if I run this, is it private? Yes, it is. See, inside setName, the first time I got the person class, it's not an instance, it's the class and the first. And the second time I got the person again and the last. And so I'm saving this for each instance of my descriptor, I'm saving the information of the attribute name. Now if I restore the thing that I cut, of course I cut the wrong thing, what am I doing? No. I have to write it again. So what I'll do is, oh, I know, I can just undo. Excellent. I'm so clever. Okay. So now, when I do, now I need to rerun it because I didn't get it in the first run. Exactly, so I got the prints nonetheless. And now I'll create a John Smith. And now if I do John.first, this looks like an attribute. I'm going to look it up in John. John doesn't have it, but the class does. But wait, first is a thing that has a get method. So I'm going to run the get method, and when I go into the descriptor, self is the descriptor and object is the person. But self knows its own attribute name. So the descriptor knows that it was assigned to first on line 15. And so this should work just fine. And I get the name. And let's just make sure that last also works just fine. And I get the Smith. And if I do assignment, hopefully it doesn't work. Of course it works. Right. So then what's happening? What's happening now is that I just defined a name. Where is it? I defined the first in my object John. So now when I do the lookup, I find the first inside the John, and so I don't get to reach the descriptor. So the way this needs to be fixed is by raising an exception inside set. So I would go object value, and I would just throw an error. So this should be enough. Raise, Rodrigo, please don't do this. Stop. Okay, and now this should work. And if it doesn't, you can boo me off stage. Let's do John is a person. John.first, does it work? Yes, it does. Can I assign to John.first? Hopefully not. And I get Rodrigo, please don't do this error. I forgot the error at the end of the name of the exception. So this is how you can create a general descriptor for read-only attributes. What's the key point of this? It's that you can use setName to notify a descriptor of the name that the descriptor was given, which I find this just brilliant. I mean, you write an assignment and suddenly you know the name of your own variable, obviously in certain contexts. I find this amusing. I don't know if you do. If you don't, there's something wrong with you. I'm sorry. There's no other way to put it. So, this was a short look into the world of descriptors. There's lots of stuff I didn't tell you, and then there's lots of stuff that I don't know yet. So there's lots of stuff twice that you can still look up. Now let's do a quick question. Who's used Python before? Probably this didn't change, right? Now the thing is, I forgot to tell you, and I was about to blow my conclusion. Let me define a quick function. It doesn't do anything. Now let me take a look at the things that f has defined. And if you peel your eyes for it, you can find a get here. Can you see the get? What does this mean? It means that my function is a descriptor. And as it turns out, if you dig deep enough, the reason methods work is because functions are descriptors. Let's say it again. So functions are descriptors, methods use descriptors. Did you get that? Have you ever used a function? Okay, so who's used descriptors before? Can I see all hands up because you've all used methods? Right, so everyone has their hand up, and so that's how I used descriptors to control you today. I hope you didn't feel very controlled. Now, I appreciate your time. I appreciate you paying attention to me. My name is Rodrigo. I've written about descriptors and the things I didn't tell you on this QR. Well, the QR code takes you to a book that I've written. It's free, so I'm not trying to sell you stuff. Now I'm going to try to sell you stuff. I also do corporate training and online courses and webinars, so if you want to learn more stuff, feel free to chat with me. I like gelato, but I don't make gelato. That was just to throw you off. And again, I write some books. This is one of them. If you have any questions, come talk to me after. Thank you. Or questions now. I think we still have like 3 minutes. Yeah.
What does the underscore argument, the one you refuse to talk about,
right.
does?
I'm not against it. I just didn't have the time. So, did you all hear the question? So the question was, what does this thingy? What's this, right? And we can actually take a quick look by. Let's go to a simpler one. Let's do print CLS print. CLS. So I'm going to exit. I'm going to run, this is the descriptors file. And I'm going to create a quick John. Actually, I don't even need a John Smith. So if I do person dot name, I'm trying to look up name in the person. But name is a descriptor. So I'm still going to enter get. Now the question is, if I just have the class here, no instance, just the class, what's the person that I'm getting here? None. I'm getting no person. But Python needs to tell me something about the lookup. I need to know why I was looked up. And so I get the information of the class as the third parameter. So if I do this, what am I doing with my life? Okay, so I got the error after the prints, right. So let's focus on this. Let me scroll here. So I'm inside get from line 3. Then I get the person is none, because there's no person. And then if I scroll one line, I get the class that was looked up. So this argument here is always the type of the class. If I have something here, then the next thing is the type of that. But when I have nothing here, then this gives me the original class. Yeah. Yeah, go ahead. I can repeat.
Super quick.
Oh, okay. Yeah,
in the last example, if I change the underscore last or name attribute, it also change first and last, or no?
That's a good question. And the answer is it will. Why? Because if I change this, when I then access first, notice how first, again, it's a descriptor, so it's going to run the get, and notice how the get accesses the... Sorry? It's not No, but again, Python is a language for consenting adults. So you can always do whatever you want. It's just that at a first look, it looks like read-only. But the only thing we did was mimic property. And by the way, property is a descriptor. So property, static method, and class method, those are all descriptors. And that's why you don't usually use descriptors, because the main use cases, they're already accounted for. Right? So this is a very powerful feature that you use all the time with methods, with properties, class methods, and static methods, but you usually don't use it explicitly, because all of the good use cases were already implemented. Yeah.
Thank you again, Rodrigo. So, applause for this room as well. I know for sure that you'll stick around because we'll see you in here on Saturday as well, right?
Yes, in this
no
same
spoiler,
room.
or you want to give spoiler?
I'm going to
No
be
spoiler.
talking about non-technical lessons I learned working full-time on open source.
That's super interesting as well.
Yeah.
Thank you again. So see you again in 10 minutes here. Stay here, or feel free to change the room. use the functional programming. It's a very interesting approach. Artem was involved also in a different European community for Python, so you want to spread the word about that. Otherwise, we can start with interesting videos.
Yes.
Yeah.
Basically,
so, great applause to Artem,
yes.
and please.
I just want to start because I'm so excited. And today talk, actually, the talks, they entered with some aviation theme. And I really enjoyed that because I was aerospace engineering before. And what you could see here is the effect that called the compressor stall. It's when the compressor on the engine gets so much air that it cannot sustain the combustion. And it's a very dangerous effect. And that's the situation I am now, because I'm so fascinated about functional programming that I'm this misbehaving compressor. So I'll try my best to put all my ideas into words. I'll talk about functional programming, and except of the things that you could find in the internet, I'm trying to address the unique gap that you don't usually see there, because functional programming is cool, but it takes some time to really comprehend that. And there are some difficulties on the way, especially if you're a Python programmer. And my goal for the next 25 minutes is to get you some taste of what functional programming is, and maybe not going deep into the jargon, but show you on this specific example how it looks like. And then if you go to other languages or you go to Python documentation, you will read how they named, but we'll see them in action. So this slide isn't purposely blank. And here, actually, I'm talking about my goals. Well, the goal number 1 is to inspire. The goal number 2, I just want to make it very clear. I'm not saying that functional programming is so advanced that you will forget your imperative style. No, it's just the way to structure the programs that help you to express maybe better your thoughts. And then, well, by the end of the day, we all write programs. And yeah, it's very hard to distinguish what is the functional programming and what is the imperative programming. I also keep the slides wide, so just stop me a bit and think what can come next. And the next thing is like one of the most influential blog posts out there that I actually keep in reminders, and it sends to me every month, is one written by Peter Norvig. And Peter Norvig has this beautiful article, Teach Yourself Programming in 10 Years. And then, yeah, you could actually spot from the title that we are not talking here about like months, and we're of course not talking about like 25-minute presentation. So programming is hard, and it takes some time to really understand that. 1 year and a half ago, I actually, yeah, and as I said, I read it monthly. 1 year and a half ago, I switched my stack from being Python and Spring Boot to something which is called Scala. And Scala is a unique language, so it's like has a combination of functional approaches, and also it's based on JVM, so you have access to whatever Java ecosystem expands to you. And to be very honest, reading this blog post and this piece of advice before, I was like, okay, why should I learn half a dozen programming languages? Why would I care about like Java, C++, Lisp, or Haskell? But now I really understand that. But it's not like something that's coming like overnight, so you really have to live through that. And I got this through the lens of the functional programming in Scala, and I really want you to share my story so that you go and you expand a bit your horizons. And the way I think this is important, because usually each of the programming tutorial or programming book, it guides you towards something that works. So you open the documentation, you want to implement some API or something, you end up in a situation when something works. But as you know, in programming, this is the most common line. So if something works after reading half an hour doc or tutorial, we would be out of the work. So because we will not have something to debug, and our programs would be perfect. What about functional programming? So Python was not initially designed as a functional language. And you could read, and actually Guido has a post about that, what's like Python and functional programming. And he said that, yeah, Python was mainly inspired by object-oriented languages like C, and then all the children like C++ and Java. But it has some functional capabilities. And yeah, and working on this topic of functional things and see the complete picture, and how it's possible to structure your programs in a functional way in Python, let's consider the specific examples of just take a simple CSV file that consists of the 3 columns. The first column, the name, the second column is the score, and the last column is the grade. And we put very basic task for us, just to compute an average of this class of 8 students. And to have just a baseline, so I go to ChatGPT and I ask like, hey, ChatGPT, you're an experienced Python programmer, just give me the baseline for this solution. And it gives something to us, and I would use it as a baseline. Without having much context that I just told you about the task that we're solving, how much time does it take for you to understand what this code does? So you need to parse a bit like, okay, you first need, is it working? Yeah, you first, no, it's not working here. Yeah, it's working here. So you first need to understand where you actually enter the program. And you see that you enter the program through the function. Then you need to go to the function definition and see actually what's going on here. And to be very honest, like without me knowing what I asked ChatGPT, it would take maybe half a minute or maybe a minute to really understand that what the code is actually doing is printing the average of the class. If you're exposed to polars or any other data frame library, maybe you would solve this problem a bit differently, and maybe you would write code like this. And I would argue that this code is very easy to understand, and it's immediately clear what was our intention, because without even knowing the polars, I can read it as as a text. So I could tell, hey, something, read the CSV, select something, cast and min. And then if I need to change it to not to min, but to some percentile or anything else, it would be just a change here in my expression to the computer what needs to be done. And this is a clear illustration of the functional programming. And now, this is our final goal. Let's try to abstract ourselves from polars, and let's try to implement these concepts in a functional way using Python, but without any data frame library. And basically, that's what we'll explore today, how to go from something imperative on the right, on the left, to something functional on the right. And as an important disclaimer, yeah, I really like this phrase. If you can, it doesn't mean that you should, because, for example, in the end, we'll see that actually the solution that we implement is not that optimal, but it's actually working quite well on the small data sets, but it's getting like, quadratic complications along the way. So that's how the usual tutorial looks like. So it throws lots of functional programming definitions, etc., to you. We'll take the different a bit approach. So we'll see each of the thing in action, and then you will name it whatever you name it. And then our final goal is to arrive to this point. So how we would arrive there? The first goal, at least what we do, as soon as we see something cryptic, this is a ChatGPT code here, and it takes time to process, we start to split it into the functions. And that's completely fine, so we all do that. And that's the first iteration of our refactoring. So we extracted this huge read CSV and compute average function into 3.1 read CSV file, and then extract column and calculate average. Looks perfect, and maybe that's where we will stop without knowing much of functional programming. And it's actually, some tutorials could stop here. So they say that, okay, we refactored, now the functions is easier to understand, good, our program is better. But if you look a bit closer, and this is exactly one the thing, so how do you think how many things this function does? So do you think it does one thing or more than one thing? So it does more than one thing. And if you look a bit closer, we see by the function signature here that it takes 2 parameters, index and the data, and then something cryptic happens here in this generator expression. So we strip the column, then we take the index, and then we cast it to the, from string to integer. So in reality, this function does 3 things. And what functional programming tells us, and what I always keep with me, so it says that if there is a function, what it should do one thing and do it well. And this is big. So this is very simple, but very heavy concept. So we know that we can refactor this function into the 3 ones. We can extract column, remove row, and convert to. And then our program would look like this. So I would say that, okay, it's maybe a bit better to read now. So at least when I scan the main body of the function, I see that first we read CSV, then we extract the column, when we remove the row, and then we convert to float. good, but it's still not very functional, as we could see here. And next question becomes how we can make it look like this. And that's where we need some theory from functional programming. So, and to arrive to the point of the result that would be computed as the steps, we need to understand what is the unary function, what is the carrying, what is the composition techniques that we can apply. And well, I promise you I will not have much math here, but basically first what we need to understand is the carrying, and this concept was actually appearing even here today on some of the talks. And the idea is very simple. It's come actually from the mathematics. And if you remember your school algebra, you remember that if you have multiple functions, whatever you do, basically the result stays the same. So, and basically that's the same idea. You see here there are 3 blocks of 3 different colors, and whatever you do with them, the result stays the same. And the idea of carrying is to change how the function signature looks like, because in the first example, the function takes 3 arguments, and it takes them at a time. In the down example, the function takes only 1 argument, and then it goes from 1 block to another block to the 3rd block to construct the final output. So it might look a bit complex and cryptic, but if you look into the code, that's how it's actually done. This simple example, it's actually very powerful, and that's one of the things to understand this cryptic concept of the unary functions. So, and if you concentrate here on the generator, you could see that, okay, actually it looks very, yeah, it takes some time to process, but as soon as you get it, you understand what carrying is. So you see the result here, it's computed as a +2 and then 3. And you could see that if I just zoom in here in the first part, which is a +2, we just apply the first argument, which is a to this function. And what function returns? It returns another function that now takes the second argument b. And that's what the carrying is about. So we can call our plus as a function of 2 arguments. So first we call the plus of 2, and then we add the 3. And then we can compose, yeah, we can define the new function, which is called +2. Now it takes argument 2, a is replaced by 2, and what it returns the function that will take a parameter b and add 2 to it. So, and this is a concept of carrying. After we have this, so it's quite powerful because we can compose the functions if they are the function of the only 1 argument. And for example, we can write quite a complex expression here and see that, okay, we define the add2 function +2. So, and we can do the math actually. Here we have 2 + 2, we have 4 multiplied by 3, 12, and subtract 5, the result is 7. And this is how, what is called by, function composition, and what this carrying is about. Another thing is that, yeah, in Python you can import the pipe module, and that's how you can call these functions in a pipe. How it's applied to our example with CSV file. We want to define the function to extract the columns. And what this function will do, it will actually return another function, which is called carried, that also kind of a function. So I think here it's just an example of how, yeah, it's an example of the slide, that theoretical slide that we had before. But implementing the higher order functions and carrying, we could rewrite our Python program now with this pipe operator. Because you could see here what we are doing, we ended up with having some extract column functions that now, well, you see that the carry operator appeared on the top. And basically what it does, it just unpacks it and does, if the function takes 2 arguments, it splits it into the sequence of applying 1 argument and then another argument. And I would argue that this one is actually quite easier to read. But the problem that exposed you through languages as Scala, you could ask, like, yeah, but what happens if this pipe function, which wraps in other functions, throws an error or exception? And this, yeah, and this gets a bit complicated because you need to catch and, yeah, you need to handle errors as soon as they appear in your code. And in Python, you do it by a try except statement. Try except is quite powerful. So for example, if we have a function that divides one number by another number, we could throw the 0 division error. And then in our main body, we can write try except closure, and we would be safe. But the problem is that, yeah, as soon as we go to the final solution, we have quite lots of errors to to deal with. And this is not very functional because as soon as you have to deal with the custom errors, you need to handle them in a unique way. How we can avoid that? And I really like this picture from F# programming language, and that's actually towards the point of learning more languages that in your toolbox. And the F# and the creator of F# gives a very beautiful analogy of railway-oriented programming. What it says that, okay, each function is like kind of a railway track, and you have two tracks. You have a positive track, and you have a negative track. And whatever you do, you always keep the two parallel tracks together. And you see here, this line is actually like, this is a pipe from our example before. And this abstraction is very powerful. So basically, it allows you to treat not only the positive case, but all the negative cases as well. How to do it? In the languages like Scala, and Haskell, there is a very beautiful and there is native support for the monads. Unfortunately, Python doesn't expose it to us. And I think this is not a big disadvantage, but I think this is the reason why we are not using lots of functional lots of functional code in Python. But the idea is very simple. So as soon as you have a function, you rewrite your function to take only one argument, and you call this argument a box. The box could contain something, or it could contain nothing. And then what you get in the end, you get the function that takes only one argument, which is a box, and produces another argument, which is another box. And then inside the function, you treat the box differently. So if the box is empty, you just don't do anything. If the box is unempty, so you unempty this box with 2, you see that, okay, you do 2 plus 3, it's a 5. You put it again in the box, and you pass by to the next operation. And this is huge. This is the greatest and biggest idea. And to be honest, like looking in a Scala where there is a native support for that, I really miss this feature in Python. And for example, you could see how you can interact with the external world as well. So you could write your CSV file, which is, well, sitting somewhere on your operating system. And what you return something which is called left and right. And you'll see that left and right is coming from PyMonad package. And this is huge, because as soon as you're in a successful path, you return something which is right. If you're in error path, actually here, you return something which is left, and it contains exactly the error message, and you'll see the benefits of it later. So you could see that after rewriting the code with using this PyMonad package, you could reach you go very close to the Polar solution. And actually, what's very nice about that is in the very end, you just check if your pipeline is right, you print average. If not, it will exactly say where your pipeline failed on the way. And if we have time for questions, we can run a live demo, and it's beautiful, and you'll understand how it looks like in the real life. And that's how we simplified our code, and it looks very similar to the Polar solution that we saw before. And that's actually maybe the key here. So the first thing is that, to realize, you see that we expressed ourselves a bit differently through this paradigm. And it's always a balance, like what is imperative programming, what is the functional programming. To me, I try to summarize it and put it like in this slide, but I think the main thing is what is highlighted in the bottom, is that when you think about the functional paradigm, you're more thinking like what you are dealing with. However, when you do like the imperative thing, you need to say that, okay, I read the CSV file, I handle this error, I do this and that, and it kind of hides the path, what you really want to do. However, in functional programming, you just express, and then you give it to machine to execute this code. And this is huge. So, and as you saw, well, even in the case of the small example, you could reach actually quite a good performance. Because, for example, in a Polars, it takes some time to import this Rust library. And you see that actually on the small CSV file, all the solution, like even the ChatGPT, is faster than Polars. It's not blazingly fast if you have a small CSV file. But as soon as your tasks start to grow, and I didn't optimize my code much, you could see that, okay, we have some quadratic O here. So we still perform quite badly. However, Polars, the performance is linear, so it doesn't change. And the size of the file here, it's only 10 lines, and here it's 1 million line. Why I'm talking about all of that? So first, it's to show you how the functional programming looks out there. when you go and you start to read, you actually will end up reading about like a pure functions and something about immutability. The concept is huge. You also see that I started to put the type annotations here, because that's another thing that started to click as soon as you work with the compiled languages. So you start to look not on your functions, not like do this, do that. You started to think about them like, yeah, you take these kind of inputs, you produce these outputs, and you always don't touch inputs. And that's the idea of the purity of the function. And this is also actually quite nice, because in that way you can also encapsulate the external world. And why I think this is big, because being at the conferences, I learned too much like about test-driven development, about hypothesis and like how they can validate and everything. And then I came back to my work, and without like being exposed to functional programming, I was like, okay, good, but how I use them? But after being exposed to the functional programming and writing it in this way, actually the functions become very they started being small. They started to do one thing. They started to do it well. And as soon as you know already your inputs, you can easily go and simulate your outputs. So I think, well, that's another thing that clicked in my head. And here is a bit of the joke. The code written in Haskell is guaranteed to have no side effects. And the answer is yeah, because no one will ever run it. Well, yes, but the idea here is that, functional programming actually, it exists not only in Haskell, and I think, well, Polars is a great illustration because it exposes you something, and maybe that's the way to use the functional programming in Python. I put some references here, so actually Python ecosystem, it gives you some, packages and tools. So I already mentioned hypothesis, and after being exposed to this thing, I think I started to write a better test, and if we want, we can take a look into how the tests look like for this specific talk and for this specific implementation. And I'm coming back to the slide of teach yourself and programming in 10 years. I really think that, yeah, we are all in the huge rush, and we should have really avoid it. And we have to think about, like, yeah, you see in this specific example how other languages pushes you a bit further in understanding. So basically, if you would stay only in a Python, you probably end up your code and your optimization on the very first slide when you refactor it to 3 functions. Then if you go a bit further, okay, the function does only one thing, but it's still not enough, and you need the concept from another language to push it a bit further. And in the end, you arrive to some place where your code looks very Pythonic. I put some references here. So I really enjoy the book by Better Python Code. Actually, it gives lots of functional programming concepts. The last book is excellent, but however, it's in Scala. But Scala has a huge learning curve, but the book is awesome. And in the end of the day, 25 minutes is too, it's too small to really expose you to the functional programming. Yeah, and I hope I did my best to not end up in this combustion, what I just showed you. So yeah, and expressed my excitement about functional programming, maybe a bit, way, but it's super nice. So I really think that we should learn good programming languages, and we should take some time for the concepts to sit in our head. And yeah, in the end, we will arrive in a better place in the future, I hope, if we would know more about programming.
Great, thank you very much, Hart. We have quite a few questions.
Yes.
And then you'll stick around, right, for the conference?
Absolutely.
Absolutely, so also people in here. So we saw a little bit of the performances. Do you think PyMonad is a mature library? Do you want to see more development?
I want to see PyMonad to be in the standard library, to be honest. And I would not be used it because it's a third-party package. But and that's the difference between the languages like Scala and Python, because Scala gives a native support for that. PyMonad is more about, it's more a trick than, I would not use it in a production.
Very much. And talking about production, about the approach about test-driven development,
yes.
You mentioned briefly this
yes.
approach, this functional approach should be simplified.
Yes.
As you showed also for the line of code.
So for example, here And that's what I said, that somehow it started to click, because as soon as you start writing the good functions, it's very natural how to simulate the behavior. And here is the example, like if you go to the GitHub, you actually see that each of the functions here that I presented has a corresponding the hypothesis test. And it becomes very natural, even like what you need to do. Which function I'm opening here? It's not mirroring, and I'm struggling to extend this. Yeah, I think I'm looking into the right test. Yeah, you could see how you can simulate the real world by looking here. So we see the test compute average function, and you see that we created a temporary file. So we basically simulate our CSV file, and then we just compute it like, yeah, compute. And it becomes very natural to write this functional test as soon as your function takes one argument and does only one thing. So it becomes like a second nature. I hope this answered the question, but the answer is thinking about the function in a functional way, with do one thing, do it well, with pureness, helps you to write the better tests. Better tests, less bugs. Hypothesis also helps you to, well, discover some edge cases that you didn't account for before.
Oh, thank you. On the line of that, what if a function can fail for multiple reasons, and we want to handle errors in a different ways? If we split the function
it's actually,
into,
it's very beautiful how it handles the errors. And if I could, I'm not a big fan of VS Code. I take the PyCharm here.
Yeah, to give you the whole.
Yeah.
They also they split the function into multiple or left.
Yes, and actually Will just left, and I wanted to ask him one thing here.
Oh.
So you see that we
Okay,
use reach. Yeah, I use reach here, and yeah, that's the thing that. Yeah, that's a problem, because on this, how can I zoom in? Okay, I can zoom in here, but no, I can zoom in here as well. Yeah, I run the main method here, and as a result, we'll see what the function is doing. So now we see the success path here. It's what I mentioned. But if we go to, well, it's a kind of very complex. If we go to the data and we change the example CSV, instead of the 5, we put here, like, for example, G, and then we rerun it. So what we'll end up doing is that, yeah, you see we have a error processing data, unable to convert the float. So this is a result of having the 2 parallel tracks. So we know exactly where the error happened. And maybe the error message is not very descriptive, and I could change it to give also the value of this float. But we know exactly where the pipeline failed, and we know exactly on which value it failed. So it's powerful. Functional programming allows you to go from the beginning to the end and see, pinpoint exactly where the error happened.
Thank you very much. It's all the time that we have for now. There are also people interested in your pointer.
Okay.
And yeah, but thank you very much, Artem. If you have follow-up question, how can we find you? What's the best way to find you?
You can go to the, yeah, if I share the screen. So basically, I have a repository with all my talks. It's my family name and then talks. So give it a star if you like the talk, and go there if you need any material or inspiration about functional programming.
Thank you very much, Artem. Just as a reminder, we have a way in and another way out for the restaurant, and we have also 2 food trucks. If you don't have the tag, you can't eat, so please take the tag on the reception desk.
qualche minuto. Buonasera, buonasera a tutti. Eccoci qua, benvenuti a quest'altro talk di Python Italia. Intanto complimenti a voi, no? Che dopo il pranzo diventa un po' difficile seguire un talk, quindi vi vedo tutti abbastanza attenti e pronti per questo nuovo talk che questo pomeriggio sarà tenuto da Valerio Armuzza, che ci parlerà di un caro framework e un caso d'uso, no? Il framework è Django, per chi non lo conosce, per chi non lo conoscesse. Django è il web framework per eccellenza di riferimento di Python, di cui ci si può soltanto innamorare. Io mi sono innamorato ormai 10 anni fa di Django, no Valerio? L'ho usato per tanto tempo, ci ho fatto tanta roba. Sicuramente ascoltare quello che adesso ha fatto Valerio è importante, perché riguarda tutta una modo per organizzare i dati, i metadati geospaziali. Quindi un bel applauso per Valerio, un incoraggiamento, e passo la parola a lui.
Ok, grazie. Benvenuti a questa sessione post pranzo. Cerchiamo di combattere la cecagna, come si dice a Roma, facendo un po' di movimento. Allora, chi conosce cosa sono i metadati? Alzi la mano. Ok. Chi ha mai metadatato qualche dato? Ok, un pochino di meno. Chi ha metadatato dati geospaziali? Ok, qualcuno c'è. Quindi per quelli che l'hanno fatto, alcuni concetti saranno un po' si ripeteranno, per gli altri benvenuti a Django Metadata Inspire, come catalogare i dati geospaziali grazie a Python. Mi presento, mi chiamo Valerio Armuzza, sono laureato in fisica, in particolare in strutture della materia computazionale. Nel 2021 lavoro come data scientist in rete ferroviaria italiana. Faccio parte del team Platform and Data Management, che si colloca e fa parte del gruppo Location Intelligence, che a sua volta è nella direzione di pianificazione e sviluppo stazioni e servizi. Una struttura, un nome lunghissimo, tante persone. Questo perché ci occupiamo di raccogliere, elaborare, analizzare e rappresentare su mappa tutti i dati che riusciamo ad ottenere ed è possibile utilizzare. Come potete vedere abbiamo diverse dashboard e rappresentazioni delle stazioni, dei punti di interesse e così via. Ma perché sono qui? Sono qui perché voglio presentare il progetto che ci ha portato a creare un sito in Django per consultare e metadatare i dati e come cercare di aggiornare questi metadati automaticamente senza dover per forza andarli a inserire manualmente. Quindi per arrivare a questo processo logico ci siamo posti le domande: perché metadatare i dati? Ha senso farlo? Esistono degli standard? Oppure come si può creare un sito, un tool per questo scopo? Quindi partiamo dai dati, la base fondamentale. Quindi quando ho iniziato queste slide avevamo circa 3.200 dati disponibili per gli utenti. Quando ho finito queste slide i dati sono aumentati di 300 elementi in 45 giorni, non tanti ma abbastanza. Abbiamo un numero di utenti che utilizzano, pubblicano questi dati in maniera crescente, circa 300, quindi andava trovato un metodo, un qualcosa per poter utilizzare, per mettere ordine. In realtà abbiamo un po' detto una bugia, perché non stiamo parlando di dati, stiamo parlando di servizi. Tendo a specificarlo perché sono dei concetti che confondono, che mi confondono. E i miei colleghi tendono a farmelo notare abbastanza spesso questa cosa in maniera molto gentile. Quindi cosa significa? Significa che abbiamo i dati su un DB dove abbiamo ad esempio i dati delle infrastrutture dei trasporti o delle aree DOP e IGP. Questi dati vengono utilizzati da delle applicazioni, script Python, notebook, programmi a uso GIS come ArcGIS Pro o QGIS, e di mezzo c'è un server. In particolar modo è un ArcGIS server il cui elementi all'interno sono delle mappe, delle immagini contenenti informazioni geospaziali. E quindi, ad esempio, per le infrastrutture e i trasporti abbiamo gli aeroporti, autostrade, caselli, strade, aeroporti, fermate TPL. Per le aree DOP e IGP abbiamo il servizio delle aree DOP e IGP. E quindi, come abbiamo detto, abbiamo 3.200 di servizi all'interno che andavano sistemati, catalogati, dato dell'ordine qui dentro, un po' come Marie Kondo dei servizi. Quindi, ma dare un'etichetta, dare un dato, aggiungere un'informazione a un dato è come metadatare i dati, è proprio la definizione di metadata. Quindi i metadati sono dei dati che descrivono delle proprietà di un altro dato. Ok, facciamo un esempio per renderlo più chiaro. Io mi ricordo, magari, voglio andare in biblioteca, non mi ricordo il titolo di un libro, vado nel catalogo dei libri. Mi inserisco il nome dell'autore, il genere, altre informazioni, clicco invio e vedo, ho tutto il titolo, vari titoli, e individuo il libro che mi interessa. L'insieme delle informazioni, autore, genere, anno di pubblicazione, titolo, prende il nome di metadato del libro, fondamentalmente. E quindi esiste un qualcosa che mi descrive il metadato dei dati geospaziali? Sì, in Europa abbiamo l'INSPIRE. L'INSPIRE è una direttiva europea per i metadati geospaziali che stabilisce quali sono i valori fondamentali di un dato. Molto più semplicemente abbiamo, ad esempio, questa è un'estrazione, abbiamo la lingua dei metadati, il tipo di risorsa, il punto di contatto dei metadati e così via. Ma noi in Italia siamo bravi e abbiamo anche l'RNDT, il Repertorio Nazionale dei Dati Territoriali. Cosa fa? È una integrazione, addirittura estende l'INSPIRE e traduce i campi. Naturalmente questo cosa significa? Che abbiamo molte più informazioni, ma molte più informazioni significa che l'utente deve compilare molti più campi e noi non volevamo questo, volevamo un qualcosa di semplice, di snello, quindi che l'utente arrivasse e compilasse il minimo indispensabile, così si riduce pure l'errore, e quindi abbiamo scelto Inspire. Perché? Perché ha validità a livello europeo, come abbiamo detto, ha una facilità di compilazione rispetto ad altri standard, è facilmente implementabile nel caso in cui sia necessario implementarlo con l'RNDT. E quindi abbiamo fondamentalmente i campi necessari da metadatare. Dai campi quindi abbiamo costruito il modello logico, il modello dei dati, scusate. Quindi tabella fondamentale è quella dei servizi. Dai servizi abbiamo i metadati, quindi se io ho il servizio delle infrastrutture devo compilare i metadati delle infrastrutture. Legato ai metadati abbiamo 3 campi. Abbiamo il punto di contatto del responsabile del dato. Il responsabile del dato è colui che materialmente prende il dato, lo elabora e lo pubblica. Poi abbiamo il responsabile del metadato, cioè colui che si deve occupare di compilare i metadati, e il responsabile del fornitore dei dati, ovvero il signor Mario Rossi, lavora per l'agenzia X. L'agenzia X è il fornitore dato, il signor Mario Rossi è il responsabile fornitore dato. Questi sono dei campi necessari per andare a integrare, insomma, la tabella dei metadati. Scorrelato al discorso metadati, ma che rientra nel modello dati, abbiamo il layer, la tabella dei layer, la tabella delle categorie. I layer sono dei sottogruppi dei servizi e le categorie sono un modo per poter clusterizzare i layer. Faccio un esempio, sempre meglio. Servizio punti di interesse. Legato al servizio punti di interesse abbiamo forze dell'ordine, ATM, campi da golf, cimiteri. Legato a questi servizi, che sono in realtà molti di più, abbiamo servizi al territorio, grandi attrattori come categoria. Penso che i cimiteri non ricadano nei grandi attrattori, almeno in Italia. Ok, quindi abbiamo il modello dati, abbiamo diciamo, capito come poter metadatare. Dove lo mettiamo questo sito? Allora, abbiamo l'infrastruttura. L'infrastruttura è un po' data dalle risorse che abbiamo, ma diciamo che funziona bene, perché abbiamo tramite stationland.rfi.it/metadata accediamo abbiamo l'IIS che tramite porta 443 ci porta alla porta 888 di una macchina Linux, che a sua volta parla con una porta 80 dove c'è il web server, il containerizzato tramite Docker, che a sua volta dialoga con un container dove c'è il sito Django, UWSGI e il backend. Il backend al momento è un SQLite, poiché quando l'abbiamo tirato su abbiamo scelto SQLite, il tutorial diceva SQLite. Quindi, ok, quindi abbiamo il backend del sito dei metadati, abbiamo l'ArcGIS server, i servizi che stanno sull'uno devono corrispondere ai servizi che stanno sull'altro. Quindi quando io pubblico un nuovo servizio, questo servizio deve essere presente anche sul sito dei metadati. E qui entra un'altra domanda: come possiamo aggiornare, come viene aggiornato il sito dei metadati? Allora, io pubblico un nuovo servizio sul server, effettuo un dump del DB, una fotografia dello stato del DB, effettuo una fotografia dei servizi sull'ArcGIS server, quindi aggiorno o creo i servizi presenti sul DB tramite uno script Python e le API di Django, carico il DB sulla macchina Linux e avvio Docker. Quindi fondamentalmente questa parte qui è tutta automatizzata, questa parte qui è l'unica che devo spingere 2 pulsanti, per fortuna. E quindi arriviamo alla parte pratica, il sito. Il sito ha un'estetica un po' forse anni 90, però diciamo, si compone di 5 sezioni: base dati, che è la home page fondamentalmente, piano di aggiornamento, dove abbiamo delle informazioni legate alla frequenza di aggiornamento dei servizi, la ricerca per poter effettuare una ricerca dei servizi necessari tramite parole chiave, categoria, punto di contatto e così via. Dettaglio metadato, lo vedremo tra poco, però fondamentalmente ci serve per consultare i metadati che abbiamo compilato dei servizi, il login che è necessario per accedere alla pagina di modifica dei metadati. Il sito è realizzato con Bootstrap 4. Bene, non benissimo. L'idea era di accostarci stilisticamente e nei limiti del possibile a quest'altro sito qui, che si chiama Stationland, e dove sono presenti i servizi e le varie applicazioni. Non conoscendo bene né il CSS né JavaScript, ho provato a limitarne l'uso dove possibile. Questo potrei essere benissimo io al momento della realizzazione del sito. Passiamo alla pagina di consultazione dei servizi metadati. Allora, io accedo alla pagina, ho una drop-down list che mi permette di vedere i servizi. Selezionato il servizio, ho solo in read only, naturalmente, i vari campi. Come ho fatto questo? Tramite HTMX. Non so se lo conoscete, la conoscete come libreria, è bellissima perché permette di fare tantissime cose senza utilizzare JavaScript e innestando il codice direttamente in HTML. Questo mi ha aiutato tantissimo in diversi punti del sito. Passiamo alla pagina di modifica dei metadati, poiché, come ho detto, molti campi sono automaticamente aggiornati, autocompilati poiché sono standard, ma altri devono essere per forza compilati dall'utente. Quindi io effettuo il login, accedo alla pagina modifica contenente queste ulteriori sottopagine, abbiamo la pagina di modifica della fonte dei dati, posso aggiungere, togliere, eliminare un fornitore, stessa cosa per il responsabile dei dati, stessa cosa per i responsabili dei metadati. diciamo, la parte interessante è qui, quindi in questa pagina posso modificare i campi dei metadati. I servizi che vado a visualizzare normalmente sono quelli in cui io sono il responsabile dei metadati, non posso andare a eliminare i metadati di un mio collega che mi sta antipatico. E quindi ecco che vediamo i vari campi editabili. Qui per un fatto di spazio non l'ho inserito, però ad esempio abbiamo l'abstract che va compilato a mano nel senso va realizzata una descrizione testuale di ciò che il dato rappresenta. Abbiamo il lineage, che sarebbe la metodologia, ovvero come è stato realizzato quel dato, le applicazioni e così via, e quindi ecco che abbiamo fondamentalmente i campi. Poi abbiamo la pagina di ricerca, come abbiamo detto, che è un form molto semplice. Il piano di aggiornamento, qui ho dovuto utilizzare per forza JavaScript, ma esiste grazie a Data Table, sono riuscito a ottenere un qualcosa di decente, e un minimo di jQuery, una funzioncina, giusto per ordinare la colonna in ordine cronologico. Quindi, conclusioni. Allora, come detto, sono Valerio. Ho illustrato come è possibile creare un sito per la gestione dei metadati e dei dati geospaziali. I metadati fanno riferimento alla normativa europea Inspire, permettono una semplice integrazione con quella italiana RNDT. Il sito è realizzato in Django con un'infrastruttura Docker su una macchina Linux. Il backend è un DB SQLite, il frontend è con Bootstrap 4, HTMX e jQuery. Il sito è un unicum in azienda e va considerato più come un esperimento, ma che speriamo possa diventare un qualcosa di più grande e definitivo. Evolutive. Creare un terzo container per il DB e usare PostgreSQL. Ho scoperto che mettere tutto insieme non è sempre utile e anzi è anti-pattern rispetto a ciò che che Docker consiglia. Usare una versione più recente di Bootstrap e migliorare esteticamente il sito. Diciamo su questo punto sono abbastanza cosciente. Dove possibile rendere open source quanto sviluppato. Vi ringrazio per l'attenzione.
Siamo in anticipo, complimenti a Valerio, quindi infatti, grazie per lo spunto, no? Perché chiaramente sì, siamo in netto anticipo, quindi ricordo sempre scusami, il microfono sì, ok, grazie, perfetto, bello della diretta, ok, allora... c'è qualcuno che vuole fare una domanda specifica in questo momento? Perché ho visto che su Slido non c'è nessuno. Ok, prego.
Adesso ora immagino che questo applicativo no, ma dietro avete scelto anche Postgres per poi poter andare a fare delle query geolocalizzate, immagino, quindi dove poter dire più o meno so che ci deve essere qualcosa in questo punto, dimmi cosa c'è nel poligono vicino, eccetera, eccetera, cose di questo tipo qua.
Come? Sì, ok, mi si sente. Allora, al momento, come ho detto, c'è SQLite. Stiamo provvedendo per migrare a Postgres. L'idea è quella di inserire i VMS e insomma, per poter integrare anche magari spatial query e informazioni di questo tipo dove possibile. Abbiamo pure provato la strada di GeoDjango all'inizio per poter magari integrare meglio quanto fatto, però era troppo in avanti rispetto a quello che dovevamo fare, quindi abbiamo fatto un passo indietro, abbiamo detto ok, facciamo una base e poi costruiamo sopra e vediamo come va.
Più che una domanda è un'osservazione. In realtà, secondo me, Postgres potrebbe darvi un altro vantaggio. Potreste usare, oltre a PostGIS, anche GeoDjango, GeoJSON, che è un formato proprio che è uno standard appunto per memorizzare i dati in JSON, i metadati in questo caso, e poi usare Postgres. Postgres permette comunque di utilizzare delle tipologie di dati che sono appunto JSON, i JSON binari, e quindi alla fine ci sarebbe un altro vantaggio ulteriore. E tutta quella tabella di modello entità-relazione sarebbe molto semplificata, secondo me.
Sì, sicuramente. Parlando anche con altri colleghi, ad esempio ci hanno fatto pensare che anche un DB non relazionale potrebbe essere utile per non so, ad esempio le ferrovie francesi lo usano per metadatare usano Mongo per metadatare i dati. Sì, magari è un po' eccessivo.
Postgres già integra quelle funzionalità perché potendo memorizzare JSON binari hai le funzionalità di
Ok, sì. Sì, sì.
Ho una domanda io.
Vai.
Ecco qua. Prima la faccio al pubblico e poi la faccio a te. Al pubblico dico, quanti di voi conoscono e usano Django? Alzate per mano. Ok, allora la faccio a te. Cos'è che ha portato personalmente te a scegliere Django per sviluppare questa applicazione piuttosto che un altro framework? Cos'è veramente che ti ha detto ok, oggi inizio così, parto con Django, lo faccio con Django?
Allora, sicuramente già conosco Python e quindi sapevo come muovermi, sapevo parlare la sua lingua. Poi pure la facile, come dire, logica con cui è possibile implementare molte funzioni all'interno del framework. Quindi non so, attraverso la costruzione dei modelli che poi automaticamente migrano sul DB, che ha dei connettori molto semplici, ad esempio test molto semplice che ho fatto per passare da SQLite a Postgres. Ho fatto un JSON e poi ho caricato il JSON tramite Django in Postgres. È andato tutto liscio senza dovermi complicare o fare cose di salti mortali. Quindi sicuramente la sua semplicità nel strutturare progetti fatti anche velocemente. Ora, questo è quasi 2 anni che ci lavoriamo, okay. 1 anno e mezzo, ma in pochissimo tempo abbiamo tirato sulla la pagina, scusate, la prima pagina, quello che ho detto che è la home page, questa in circa un mese, 2 mesi l'abbiamo tirata su.
Quindi la keyword è semplicità?
Sì, assolutamente.
Benissimo, quindi mi hai risposto praticamente, perché è chiaro che
era la risposta giusta.
Per chi vuole fare, appunto, chi vuole approcciare allo sviluppo di applicazioni web, no, insieme a tanti framework, sicuramente Django è uno di quelli là che aiuta. Grazie. Se c'è qualcun altro abbiamo giusto 5 minuti, se no chiudiamo qua e facciamo un bel applauso a Valerio. Ok, grazie.
Individual farmer fields, assess soil condition, give farming recommendation, and combat deforestation. Welcome him.
Well, thank you, Luca, and thanks all for being here. Yeah, so this one will be a bit more about applications, especially compared to the other ones, I guess, but I hope you all enjoy it. So today we will talk here about these three farmers here. You see here, they're probably somewhere in Rwanda, and they have fields. Well, you can barely see them, the small fields, that's like their complete plot. That's their 1 acre. And it's my job always to try to support them with data science. And well, by doing that, we encounter a lot of struggles, and I hope to take you on this journey to show you how to overcome some of the challenges at least. So this is me. I work as a data scientist in 1 Acre Fund. Here I'm in Zambia on a plot talking with a farmer and a local colleague. This is a maize plot, and we're actually not talking about the maize here. We're talking about the trees that you can barely see, and about the project, how we were going to identify them with satellites. So you can already see the challenges if, like they're barely visible on this picture. So the problems that we will have when we are identifying them. So I will give a short introduction about the organization I work for, just for you to understand what we're doing, and also, for the data science cases to make sense. Then we're going to talk through different issues, like where's the farmer, is the information available about the farmer, how is the farmer actually doing, and what should the farmer do, how can he or she, or mostly she, improve the farming best practices. So this is 1 Acre Fund. We are in basically all of Eastern Africa, and it's very depending on which country we are, where the kind of stuff we do. So this is actually in Kenya. We see a duka, which is Swahili for store, and people can come here to take their inputs. While for other countries, we actually go visit them. They often even don't have any means to go to a store. So, but in Kenya, this is the more prosperous one. You can, I don't know if you can see it, but there's actually like solar panels they can get, or fertilizer. And we support the farmers with different kind of products, with seeds, fertilizers. We give them trees. Sometimes trees are like cash crops, so that's mangoes, avocados that they can then use to sell. But sometimes more for carbon credits. We give them microcredits, so they get funding up front and they repay later on. They can get insurance, and we give them a lot of recommendations on how to plant, the crop health, the soil health, and basically in all of these steps, data science can add a lot of support here for the farmers. And the farmers, we are on this journey with them, like it's a typical, I think it's from the World Bank that you categorize farmers or people into 4 stages of prosperity, where they go basically from hunger to prosperity. Prosperity is like if you have an Italian farmer, he's there, his kids can go to university. But we focus mostly on the hungry farmer, who's really struggling just to make ends meet. And by just improving their yield, they can at least go from hungry to self-sufficient. And then they can feed their family, the kids can maybe go to primary school. And then after they made it there, we're also helping them, especially in the more developed countries, to go to an advanced farmer, like they can have really money to send the kids to a proper school. They can have money for maybe a motorcycle to really get themselves somewhere. He's healthy. If he has troubles, he can go to the hospital. And going from step self-sufficient to advanced is a completely different story than going from hunger to self-sufficient, because then you're actually thinking about actually how to add money to the farmer. So like cash crops and exporting nuts or avocados, mangoes. So we operate, as I said, in almost all of East Africa, but also in Nigeria. We serve 4 million farmers. We started, we were so proud in 2019 when we had reached like 1 million farmers, and it's still going up like that. And we generate $200 million of profit. And it's already the first data challenge, like how do you measure like the impact that you're having? So what we do, we have farmers and we have control farmers who are not with us. We compare basically the yield, the profit that they make, and that's the impact. So we have impact per farmer, and then we have the amount of dollars that the donor needed to give to the farmer, and then we have the SROI, which is, so it can be up to 7.5 for Rwanda. So every dollar someone donates is actually adding $7.5 to the Rwandan farmers. Well, like for every dollar you donated to Tanzania, it's actually only adding 0.9 to the farmer. So we are, sometimes that happens, and then we have to take, well, basically slowly shut down Tanzania and maybe try something else. And overall, the impact is going quite up. So I think now it's about $3.5 for every dollar donated. And then, so how can data science and remote sensing help for this farmer? Well, we can help them with monitoring how they're doing. So we can monitor how the trees go, also to monitor deforestation around the plots. We can monitor how well the farmer's yield is doing. Like, yeah, like with this colorful plots, you can even, at least in the West, for the bigger plots, you can even tell like which areas of the field are doing well and which can maybe use extra fertilizer, extra lime, stuff like that. And then we can also help them with improving their efficiency. So we can use data science and Python to track like the trees, to monitor them, like, okay, where are the trees, identifying them, seeing how big they are. And then we can say, okay, this kind of trees, if it's this big, then it's actually the equivalent to this amount of carbon credits. So you should be rewarded this and that. Monitoring floods. So if a farmer is in a flooded area, maybe he gets an insurance, or maybe we can forgive a loan so he doesn't need to struggle, maybe kill his cow or something like that to make ends meet and to repay. And maybe it's better for everyone if he would just wait another season. We can tell him when to plant, also what kind of things to plant, fertilizer recommendations, and sorry. Yeah. And for that, we first have to know where the farmer is and what is the field of the farmer. And this is more difficult than you would think. Like for most of the farmers, we actually, like 3 years ago, we didn't have a single clue where they are. Like, okay, they would come somewhere to pick up, they would walk somewhere, pick up the goods, and then they would leave again. So I'm sure someone knows where they are, but I don't actually. And they could be like 10 kilometers from the point where we would give them. So then we were thinking, okay, maybe what we can do is we can do some automated fields delineation. So then we can create the fields, and then we can ask them like, hey, where are you? Can you point to your field? And then we can put that in our database, and from then on help you with recommendations. And yeah, because in the end, as I said, we have like 4 million farmers, so it's quite a task to go and walk around maybe the plots, visit them all. So we went to do something with, we worked together with Berkeley with a fractal residue net, and it's encoded decoder architecture. And in the end, we try to predict the extent, which is basically the inside of a plot, the boundary, which is the border of the plot, and the distance. And the distance is like 1 if it's the center, and 0 if it's the boundary, and also 0 if it's outside of the plot. And well, when doing that, we had a lot of challenges. Like one of the things is that we don't actually label all fields, of course, because we can only label our own fields and not the farmers that we actually don't know. So we fixed that by evaluating only the labeled fields. So by evaluation, we would skip just the whole area that was not labeled. And we were also not sure about how many labels we needed. So we did some testing there, and then we asked, we sometimes ask people to label a few more, maybe by hand, on a satellite image. And of course, as you can see, sometimes the fields are just too small, like we don't even have pixels, like we don't have the information to identify it also by visual eye, you couldn't fix it. Sometimes it's a low contrast. So if you think about the one where I'm standing with the trees, the problem there is that just he stops like somewhere on the plot. So where is actually the end of the plot? How does that work? Sometimes it's more arid location. And we had used different metrics. So we used overall accuracy, F1 score, and the one we really tried to optimize is the MCC. And for every plot, you can see how well we did by comparing the area of overlap with the area of union. And so then we were almost there, and then Google actually showed up and they said, hey guys, can we do it for you? We have all these GPUs. And so we ended up doing that, but it's theoretically it's the same. And let me show you how that went in the end. So for this, we built our internal Streamlit app. And sorry, let me, yeah, I can put it there. So, okay, we created this Streamlit app. It's in Data IQ, so you'll probably see colleagues logging in and stuff, but it's something we can ignore. And let me see, let me get their plots. And let me also get some labeled fields that we can zoom in on. And let me just select one by ID. And then we can see how it went. And maybe I should change this to satellite just to make it more interesting. And as you can see, this already went quite well. Like we see the different fields that are labeled there. So you can see the boundaries, and you can see that the boundaries, and I can maybe sometime like toggle this. Yeah, you can see actually that it's not one field, but at least it's like 8 fields or something that are labeled quite well by Google. So then in this case, we could maybe go to the farmer and ask like, okay, it's apparently not 1, but we have found 8. So can you tag all the ones that are yours? And then that way we can, we can know where you are. But it's actually not that possible because you will see that he also missed some of them. So, okay, we did a really cool data science stuff, but it's actually quite useless. like we can't really, we still don't have an approach really how to do this now. So, but one thing we figured out is that we can ask them how to walk around the plot, and then afterwards, like map it and see where it doesn't match and see how we can overcome that problem, and hopefully also for a lot of farmers at least have it then correct, like be like, okay, these ones are all correct, let's just use the lines that were found by Google in this case, and for the other ones, let's just, maybe walk around it again or something like that, or maybe just go for what they've walked around. Then there's also point detection, like for the trees, we want to know where the trees are planting. This is a horrible story altogether again, because often they don't have proper devices to do this. We don't have the capacity to give them like the Garmin devices, and even they have like have like a meter or accuracy or something like that problem. So it's still, if you're a meter away from the tree and you've seen the trees are very small, then you're quite far off the tree actually, and it's quite useless the way you tag them. So we're trying different ways. We try different approaches to ask them, like, okay, can you maybe tag the tree 5 times or 4 times or 3 times? And then by using some logic about the accuracy, often it does give you the accuracy and can tell you how far it is off. And also by combining them, we could see like, okay, what is the best strategy and what will work best. So 5 points, you see that they just become impatient and just start button bashing before it's even accurate. So especially with the green one, is really just opened it and started. So that's doesn't work. So then there's 4 points and 3 points. And the convenient thing with 4 points is that you can take the one that is furthest off and then ignore that one, and then you end up with this one. And this is actually quite accurate. And for this one, at least you know for which ones you're off. And for the ones where you know you're not off, then you actually identified quite properly where the trees are. So this is what we're doing at the moment. And now we know where the farmer is. And well, then the next step is to actually start doing some data science. So for that, we used Google Earth Engine. I'm not sure if there are people familiar with Google Earth Engine? So it's like 2 years ago, we were not using Google Earth Engine. We were doing everything by hand, working with universities, trying to collect all the information manually. And yeah, that was a hell of a job. It was like a full-time job to really make sure that the data was all the time accurate and up to date, and that the servers didn't break. And so then we moved away from that and started using Google Earth Engine, where you really can collect all the information that you need. And like, for example, one data set we use often is ISDA. ISDA is information about the soil. So it gives you information about, for example, pH is an important one for us. Here we go. So pH, but also nitrogen, and basically whatever you want about the African soil. And it's really quite easy to use. They work quite well. The descriptions are there. They tell you like, okay, these are the 4 bands that basically the raster uses. And they give you some example code that you can run to visualize it in a way that makes sense, depending on the source you use. And then you can actually, like, we're doing this on the fly, you can run it, and then it's just there. We have this interactive map of all of Africa giving us where what the pH value is of every point of land. And sorry about this. And there's also, for example, deforestation, which is really important for us. You can plot the deforestation and you can see where the forest was removed. And this is not only available in their JavaScript viewer, but it's also possible to just, by really using only a few lines of code, to have a map spin up. And then, for example, this is a split map. I hope this. And really easily we can spin up the Streamlit. So it's GEE map is the package you need. And then by just these few lines of code, we now have like this split map, as I said. So, sorry. And you just do it by importing EE, which is Google Earth Engine, and then EE.authenticate. And then you just need to get your authentication somewhere, and then you can start using it in Streamlit or wherever you want to use it. You can also, instead of just using like the visuals to see what's going on, you can also create more like a flow that it integrates with pandas or GeoPandas in this case. So where you just tell him, like, okay, I want to have the deforestation image. Okay, let's change the GeoDF to Earth Engine. And then we can just select the loss and reduce it. And we have a GeoPandas data frame, but now with added to it the deforestation. So if you have a geo data frame of all the farmers, then from now on you can know really for all the farmers if they were involved in deforestation or not. And so we do that a lot to do it like that. So we often collect the information in Google Earth Engine, then we transform it to a data frame, and then we have a data frame that we can actually run the models on, just like we used to, just with scikit-learn and stuff. I think it also integrates with their own Google products, but I prefer just to use it like I'm used to. And then if we have predictions or something, what we often do is turn it back into a raster file again. So we turn it back into a file. that can be accessed, and then we deploy it. And we deploy it to API endpoints. And that way, someone can come in, just give you a latitude and a longitude. And then, for example, with a Lime recommendation, you can just tell them, like, okay, your location is here. And for this person, we recommend no Lime. Or we recommend this kind of seeds. Or even for rainfall, we have like automated, like we run the same script every day. And then we have new planting date recommendations where we tell the farmer like, hey, rain is coming your way. Maybe you can start planting tomorrow or something. One thing with the yield, what is always important is the NDVI or the EVI, but it's basically how green the picture looks. So if you want to know like how the maize is doing, you take the images and then see how green it is, and it's often an important indicator for how well the farmer is doing. But as you can see, we're always collecting a lot more information about the fields, just things that we can collect with Google Earth Engine and then extend it that way. And one final challenge that we had for a long time was really like, okay, if you have all these API endpoints and stuff, then how are you gonna tell the farmer when to plant? Because if you don't know where he is and you're doing everything on paper, it's quite nice that you have all this cool data science, but it's still not feasible to actually help her in any way. So throughout the years, it became more and more possible to support them with the advanced technology. In Kenya, we are able to build apps, and we integrate with the apps with the rasters that I shown, and we can give them real-time advice. But for a lot of other countries, it's possible to use USSD. I'm not sure if people are familiar with that technology. It's if you have a feature phone, you can send an SMS. Some of you might have known it's like star, then you give a code, you do a hash, then another thing pops up, and it's bidirectional. So you don't need a smartphone for this. You're basically using an app, but by just sending text back and forth. And that way someone can go to our like star, I don't know, 118 star, 1 hash, and then he can ask, and then he will get the answer like, okay, plan tomorrow, something like that. So he doesn't even need a smartphone for that. So with limited resources, he can still then access like all this satellite information and know what are the best practices. So are there any questions? Yeah.
Thank you very much for the talk. And yes, we have a lot of questions. And the first one is, what geodata format do you love most and why?
So I think GeoPandas works well as like as when you're working with data frames, and now we use Google Earth Engine for the rasters, so we're actually not really touching any rasters themselves anymore. But before we used that, we used Raster.io, which worked really well. So and then often you don't really have a choice on which kind of formats will come your way, the raster files, because there's like a crazy amount of formats out there, which are all very similar, if you ask me. So then the TIFF files work best, I think. It's my experience, but yeah.
Cool. Would you recommend switching over to Dataiku? I don't know what it is.
It's okay. This is maybe not really for this conference, but yeah. Yeah, but it's not, okay, it's not really, my answer is not really fair, because we are an African NGO, so they give us everything for free. So if you get it for free, yeah, I would definitely recommend it, but I don't know about the cost. But the tool is really, so we still do everything in Python. It's very Python oriented, so it's definitely not something that would replace your coding and stuff, but it really helps me with a small team, like the small team show that we're running. It's definitely would have been impossible without a tool like this. Yeah.
The next question is, how long do you normally work together with a farmer? I think it's a matter of collaboration. How long lasts a collaboration with a farmer?
How does that work? So the stores that you've seen before, like in Kenya, there people can just come in and take something and then move, but it's not typically something we do. It's mostly a multi-year thing where people signed up, they repay during the season, then they collect, and often there's also some perks for them, like if they basically advance to the next year, they can get more credit, for example, because they turn out to be trustworthy. So yeah, there are many farmers who are there for like 15 years already or something. Yeah.
Wow. Which remote sensing do you also register trees being cut, burned after carbon credit allocation, and have a policy to deal with that? It's a complicated question.
Well, I don't think that. Yeah, it's a good question. I think they register. Yeah, I think the. I don't actually know the answer to this question. Okay, less from a carbon credit specific point of view, but more from improving the world. I think it would still be like the trees that you saw there. They're planting there. They're giving moist to the soil. They even fix nitrogen and add it to the soil. And if the farmer decides to, well, it's actually part of the plan that the farmer cuts it down and then starts burning it, because they're using charcoal anyway to cook. So they might as well plant their trees and then cut it down instead of going to the rainforest and get it. So, yeah.
Makes sense. And are there any security or privacy concerns for the resulting application?
Well, the nice thing about using open geospatial data and stuff is that often you don't have to worry about that a lot. Like someone can just give you like a GPS coordinate, and then you can give a recommendation on I don't know what. So we don't have to worry about that much. And I don't see any, but maybe.
All right. Who owns the data? Mostly the same question. The farmers are at or 1 acre farm?
Yeah, so that's a good but very theoretical question, I'm afraid. Like if you're a farmer on that hill, you're not like the right to be forgotten and stuff. It's the GDPR is often there in a lot of these countries. They adopted like the European rules, but if you're a farmer on a hill, do you own data? Yeah. I'm sure theoretically it's like that, but I think it's maybe more a discussion for the future. Yeah.
How bad is it when you don't detect the whole farm plot? Aren't your advices and crop prediction already 80% useful?
Yeah, probably. Yeah. But then you can also wonder if you just tag like the center of the field, if that would not be enough. Like that, definitely for a lot of use cases, it adds already a lot of information. So we are actually doing that. Like we are like, okay, even if we're not completely accurate and stuff, let's just go, because 80% of my use cases will still work. But but if you really want to use it for insurance, for example, then you really have to know, like, okay, is this area flooded or not?
Do you use Google Maps satellite view or have other providers like Maxar?
We use mostly, well, okay, here this was just OpenStreetMap and built-in stuff from Streamlit that's just there, but just to visualize it. But if I really want to know, like if I want to check how green a field is and stuff, you can't really use that because, I think we already reached the zoom level where it's like, okay, like it won't work. So there's especially initiatives from the Norwegian government that open. If you're in Africa, you get a lot of stuff for free. So then, so there's really high resolution images available, paid for by the Norwegian government, and we use that.
Okay, we have finished the time at our disposal. So thank you very much again.
Thanks. It's planets.
Planets?
Yeah. Yeah. Do you want to use it?
No, because we're
You should. Okay.
Should I introduce you before you introduce me?
No, I just introduced you and I start.
I know, I was making a joke.
Oh.
Should I introduce you?
I'm focused. I'm in my comfort zone. Yes. Okay, welcome to Panino room. I remind you that if you want to ask some questions or doubts or something, you have always a Slido dedicated of this room. So use it and we will read all your questions accordingly to time. Now we have from pixel to plots, transforming lives of, the other one. Analyzing COVID-19 protest movements, a multidimensional approach using geosocial media data from NEFTA. She's a researcher and PhD candidate at the Department of Geoinformatics at the University of Salzburg. The spread of conspiracy theories on social media through protest movements is a societal problem. For effective countermeasures, understanding the movement's spatial manifestation is essential. This talk explores how leveraging a geosocial network analysis of Twitter data can address the issue. Welcome.
Thank you. Thanks. So 3 years ago, COVID-19 happened, and it had a huge impact on our daily lives. We had national governments that imposed policy measures, all targeted at containing the spread of the virus, but still they cut into our personal freedoms. And so these policy measures were, and I would say rightfully so, heavily discussed on social media. We also observed something else in that time, which is the spread of misinformation, that is the voluntary spread of false information with regard to COVID, and conspiracy theories. The picture I'm showing you here is from a protest gathering in Vancouver 2020. So people came out to protest, and you can see one instance, one example of such a conspiracy theory. This particular one made Bill Gates somehow responsible for COVID. But the thing is, the surprising thing is, people, or the belief was so strong that people actually go out on the street and protest for it, right? That's something you have to imagine. Another instance was the 5G conspiracy theory, which also happened during the time of COVID. So people made telecommunication technology, I would say, somehow responsible, linked it to COVID. And what happened? Well, cell towers in the UK were attacked and set aflame. The point I'm trying to make is the social, like conspiracy theories and misinformation, they spread in the virtual social network world, right? But they have a direct impact into our, I say, real geographic world, attacking cell towers, protest gatherings. And that's what I wanted to study, and this is what I want to talk to you about. So what I did was I analyzed the COVID-19 protest movement, misinformation, conspiracy theory targeted against anti-vaccination mainly, for the use case of Austria. And today I would like to show you what I did and how I did it. So I will first talk, of course, about the data, the Twitter-based analysis, and the approach that I use, going through network analysis, a bit of semantic analysis, and the main focus always spatial analysis. And of course, we will discuss the results here. What I would hope that you can take away from this talk is, the first point is how to use social media for researching a movement. This can be, the things that I'm doing can be applied to other settings as well. And with that, I hope that you also understand why the availability of social media data is so important and so crucial for research. And of course, this research wouldn't have been possible if the open source libraries out there wouldn't be developed by the people and wouldn't be taken care of. So that's also another important point. So with that, let's get into it. Let's talk first about the data, and I took an example here I think you can all relate to. This is a user profile of PyCon Italia on Twitter, and I just want to look at it and just make it clear what kind of information we have in Twitter, because the kind of information is kind of manifold. First of all, we have the user information. A user can be a person, but it also can be an entity, an organization, in this case, PyCon Italia. They provide a short description. Importantly, they describe a location which I would say they define as their, I call it sphere of influence. That's how I describe it, so where they interact. And we have information about followers. And if we look into a specific post, we see content, textual content mainly, a tweet, also known as, images, videos, data, a date, and mostly metadata around that. So that's the information that we have available, really rich. And what I want to focus on, or what I try to focus on, I don't know why this happens in LibreOffice, I'm sorry for that, is the geospatial dimension, the network dimension, and semantic dimension. What do I mean by that? Geospatial meaning location of users. I want to analyze how location comes into play. Let's say, which kind of conclusions can I draw through looking into location? By network, I refer to user-follower relationships. You will see that in a second. And semantic means essentially the tweet text. And now let's look into each of these dimensions individually. When I talk about network, I mean the following. Look into these two statements. We have the first one, user 1 is followed by users 3 and 4. And the second one, user 2, is followed by users 5, 1, and 3. So this information can be modeled or represented in a graph structure. So we can say users are entities, nodes, and their relationship can be modeled as an edge in a graph. And if we take that, we retrieve two separate graphs and we put them together, we end up with the graph structure on the right side. Meaning in our Twitter case, the node are Twitter users, people who interact on Twitter. The directed edge means user A is followed by, ergo the user gets their feed. An information flow can happen. That's clear. Why do we do that? Well, networks have proven to, let's say, provide an interesting form of conclusions. If you analyze network structures, and I will show you that later, you can draw interesting insights from the structure, in this case, about the social network. Now, I told you that I want to study the Austrian COVID-19 protest movement, and how do I do that? Well, there's a thing in Twitter, people follow people, especially in the extreme cases. If we talk about far right, if we talk about conspiracy, people tend to follow other people due to like-mindedness. This is research in social sciences. So what we did, and this is mainly work that my colleagues in the communication science department did, they essentially, at the time when COVID was, or the conspiracy movement, the protest was high, they browsed through journals, they browsed through newspaper articles, Twitter, Telegram, all kinds of channels, to identify people in Austria that were active in the protest. Active means they were spreading misinformation, maybe even conspiracy theories, maybe even mobilizing to go to a protest. This were political actors, doctors, like all over the spectrum. What they did, they compiled a list of 100 people, and we used that list to crawl the network. So those were the start users. Those were the people that they identified. We retrieved their followers and even their followers. And this is how we build up the network, and this is how we ensure that the network that we're studying is actually related to COVID-19 and the protest. And how we do that is quite simple. Once you have identified the people on Twitter, the users there, you can retrieve their IDs, just some pseudocode that I put there, and you can just essentially iterate through the user IDs. And when Twitter's API was still accessible for research, you could actually retrieve the followers, and I would say all of them. It took a bit of time, but you could retrieve a huge list of network data. Not possible anymore, or not for free. What we then do is, of course, store the network data. In this case, as the data was really easy to handle, so it was not as large, and I didn't need any consistency, redundancy, atomicity guarantees that a database would deliver. It's really straightforward to just put it into a CSV file in the form of user ID, follow ID, iterate through it, and use network X or networks, I don't know how it's pronounced, to build a graph down there. And once you have the graph structure with network X, you can essentially, it gives you the Python representation to perform all kinds of, let's say, network-related algorithms on it, community, centrality, etc. I'll show that to you later as well. So that's the network dimension. Keep in mind we have users and followers on Twitter, a directed edge here between them. And with that, let's talk about the spatial dimension, how I call it, or how location comes into play. In the case of Twitter, it's a bit trickier, the one that I use. So look into this example. This is PyCon.de. They did not provide, or they provided Germany as a location in their bio. And I told you that we assumed that the location that the people provided is their sphere of influence. Well, this might be true for PyCon.de. It's Germany. It's probably active all around Germany, but it's really not like fine granular enough. For the case of PyCon Italy, it's a bit better because that's city-level resolution. They provide Firenze, so we assume they're just active on Firenze. And if you think about not organizations, but people, this might even be more true, because if I say I'm in Salzburg, Austria, this probably also means I regularly interact there, probably. So that's the assumption that we made, which is, of course, ambiguous and tricky. Once you have that, that's just a textual description of your location, right? It's just a string. And what we need is a geographic representation of that string, meaning we want to know the coordinates of Firenze or Germany, or whatever that is. And this process is called geocoding. Ever heard of that? Good. Geocoding essentially is what all of us do when we open Google Maps and type in, please route me to this hotel here. It takes a reference, Grand Hotel Mediterraneo, and translates it to a coordinate, matches it somewhere, and routes you there. We can also use, because Google Maps is, after a certain point, expensive, you can use OpenStreetMap, Nominatim. Same service, you just provide a string, Firenze, and what it gives you is the geographic, let's say, the way we refer to that as the bounding box, right? This is the area that's surrounded, or is Firenze, let's say. This is a description of that, and the center of that. And the center is a coordinate, this is the coordinate we use. Center is most likely the city center in some definition, or it's the center of this area, the centroid here. And this is the coordinate we use for that. And that's something you can automate quite nicely using the libraries like GeoPy. GeoPy is neat because then you don't need to type that in manually. It implements already an interface for Nominatim, so you just import it, say import your Nominatim geocoder, provide a list of locations that you want to geocode, call your geocoder, send the API call, and then of course you get the location back, the address and the coordinate, and that's how we did that. And the nice thing is it is free, it's out there, it's open source. Once you have the location reference, once you know where the people are, you essentially have a mapping of user ID and coordinate. And once you have the coordinate for user ID, you still have a data frame, for example, for users, but you can also perform all kinds of spatial queries on top. What do I mean? I mean some things like give me all points around, like in a certain radius of point X, or give me all points that fall into a certain shape. And this is easily done with GeoPandas, which is, I hope I don't say anything wrong, but I think it's like more or less a wrapper, an extension of Pandas, which extends the Pandas data frame, the data type with essentially one column, the geometry column, and this is where you can operate all kind of geographic operations on it, be it projection from one coordinate system to another, or spatial queries. This is GeoPandas. It's really neat for, I would say, small to mid-sized data sets. If it gets really large, you need to think about using a proper GIS database. For example, there's Postgres and the Postgres extension, which then performs way faster, of course. It's just an excerpt of the data that I had. So remember, I was talking about users in a network. So each ID here represents a user node. And I have the location that they provided in their bio, and I geocoded that so I get a geographic reference, a coordinate. And if I take this information and plot that, I end up with something like this here. So what you see is the plot of the complete network that we retrieved when I initially crawled with the data set. And you'll already see a couple of problems. Let me explain first. Of course, the orange dots are our users, and the white lines represent edges, meaning connection between users. And what I did was plotting the users on to the location that they provided. The thicker a line is, it means more connections follow along this route. So you have lots of connections between Europe and US and so on and so forth. You also see it's a worldwide network. You know, it's because I crawled start users, layer 1, and then another layer of followers, which I wouldn't do again, because if you know current research, the degree of separation in social networks is something around 4. Means starting from me, if I do 4 hops in a social network, I end up with me 4 to 5, something like that, I think. And which means 3 layers of followers is already too much. But at the time when I wanted to correct the research that I did, Twitter's API was closed, so bit of troublesome. So I had to, like, with the knowledge that this is a limitation in the analysis, we continued, and we, I think, did our best to counteract that. So that was network and spatial. So we know we have users, we have followers, we have the edge between them, and we have each user has a geographic reference. There's somewhere in the map. Now let's talk about the semantic dimension. What also used to be possible with Twitter's API up to a certain point is crawling tweets per geography. Let me explain. It was possible to say to Twitter's API, hey, please give me all tweets around a certain location. So you sent in a GPS coordinate and said, give me a sample of the tweets. And the research group I'm in used that for the last, I think, 5 to 10 years to build up a huge database of georeferenced tweets around the world for academic research purposes only. And what we ended up for in our case, this is how powerful this actually is. So I retrieved 6 million tweets for my analysis from this database, although I was even late to the party. So I started the analysis later than COVID was a thing, 2020 to 2022. Something between 6,000 to 10,000 tweets per day in the DACH region only, limited to the users in my network. And that's a huge amount of data. So we were able to crawl, I think, something like around 1 million tweets per day, georeferenced tweets. And this was all, like, this enabled a huge amount of research. And once you have that, if you want to deal with tweet text is a bit different from, let's say, larger documents, larger text document. Tweets are short, they contain hashtags, they contain emojis, they contain mentions, and so on. So you need to deal with that. You need to remove rare words, for example. You need to also remove not safe for work words if you don't want to, or if you don't want to include them in your analysis, and so on. And once you have that, you have essentially a data set of network with spatial reference, and you know for each user in the network what they are talking about in terms of tweets, roughly. With that knowledge, let's walk through the analysis, and let's start with the network. And for that, I think I should briefly familiarize you conceptually with the concept of communities. If I tell you the gray bubbles are communities, you'll intuitively know what I mean, right? It is something, this is the structure in the network. If we translate it into the definition, it means each of the nodes, for example, in the left bubble, gray bubble, have more connections within themselves than to the other gray bubbles. That's a community. Why are communities important? Well, if you think about information flow in a network, and nodes as users who communicate, then the left bubble will probably form an information bubble or something like an information trap or social bubbles, as we say that, right? You're essentially your social bubble that you are on Twitter. That's communities, and we can detect them also with Network X with a couple of the different types of algorithms implemented, Louvain, and for modularity optimized, also hierarchical ones, whatever you need. We did that for the network I just showed you. And keep in mind that this is just the community detection algorithm doesn't know anything about geography. It doesn't take the geographic reference into the algorithm itself. We ran the community detection algorithm, and what we ended up with is this. So each color on this map represents one community. You can see the orange one, for example. It covers almost entirely Austria. It is clearly separated from Switzerland and Germany. And also, if you look closely, of course, Netherlands and Denmark are clearly visible, but even there, this region here, this is the region around Barcelona. It's a Catalan region, so it's its own community. It's its own information community. So what does it mean? We just built a network of protest actors. We detected the communities, and we just decided to plot them on the map. And what we found is they actually correspond to geographic or align with national boundaries. This means the network of protest actors actually communicates more closely within national boundaries than externally. And that's important because we know that the protest, at least in Austria, was targeted against nation states, right? Or let me put it differently, what you could have also expected is that because Germany, Switzerland, and Austria speak the same language, German, it could have also been one large community here, but that's not what we find. So that's one way how combining network analysis with the spatial dimension in the data is, can you deliver more insight, or let's say deeper insight than just plain network analysis, right? Just one example I wanted to show you. Similarly with centralities, centralities are a rank of measuring importance of nodes in a network. There are different kinds of them. I'm going to make one brief example. Think about the one node in the left bubble which connects to the other ones. So imagine this one is a Twitter user, and another one, let's say the one up there, decides to tweet about a party or drinks afterwards after this event. There's a drink going on. Imagine this node does decide not to retweet. What happens? The other community stays uninformed, which means this node has a high control over the information flow in the network. That's called betweenness centrality. So there are different ways of measuring importance in a network, and centrality is like kind of the term for that. Keep that in mind. I'm going to refer to that back in a second. Just need to talk about a concept that's called spatial clustering. So again, here when I show you spatial clustering, look on your left, please. That's clearly structured. It's clear separation, red, white. And not sure if you can see that, but there is a value below. That's Moran's I. It's almost 1. It's a measure of global spatial clustering. So if it's 1, it's completely clustered, and this one is almost completely clustered, segregated. On the right-hand side, the value is way lower, and you can also see what it means. It's like the values are more spatially random. There is not really a clear pattern, at least at a global scale. And spatial clustering is a way to assess that. It's not entirely random. If you look closely, there are like a white cluster and a red cluster. And that's something that you want to capture with spatial clustering. Now, thinking about, again, the centralities, importance of nodes and spatial clustering, what we can do now is this one here. So this is, again, the network of protest actions that I showed. We calculated the centralities of the nodes. And what we find is that people with a high importance of the network, who are also surrounded by other peoples with high importance, tend to be only in the DACH region. How do we interpret that? Well, while we understand that, the targets of the protest movement were mainly nation states, important people seem to be still in the DACH region. So we couldn't really say that there was an influence from external, which was suggested and other studies also found, especially with QAnon and the US. We were not able to detect that in that scale. I have 5 more minutes left, but I'm still briefly going to talk about the semantic part because I think it's really interesting. There are ways to deal with textual data to essentially grasp what we identify as a main topic or a main theme in the data. I'm not going to go briefly into the details. And I would like to show you 2 examples of that. So let's first look into one user community in the DACH region that I found. So what you will see here is one community that's clearly clustered around one person. Right-hand side is a network, left-hand side is the nodes on a map. There's one person, one user in Switzerland, which has a high out degree. That's why he's colored in red or larger, which means high amount of followers. So meaning this community is structured clearly around one opinion leader, okay? There's one person, or maybe 2, there's also one in Vienna, who are highly influential in terms of out degree. There's another one which is structured differently, like not that one person with a high out degree, but several ones with like medium size of amount of followers. Also looks differently. Just 2 instances. What I did now is I used those 2 communities, and what I wanted to find is, let's say, the community that's talking about the conspiracy, the misinformation and so on. Didn't find it, but still something else. If we look into this first one, which is highly influenced by this one person in Switzerland, if we look into the outputs of the topic modeling, that's mostly against public broadcasting. Do you know the concept of public broadcasting's fees? So in Germany, you have to pay a certain amount of money to the public broadcasting services, which are independent of the state, and it essentially ensures independence of journalism, from economy, and so on and so on. And those people in this community, they don't like it, which is interesting. It's not like a strong indication for any kind of protest movement, but it still shows there's a certain affinity, right? I'm gonna keep it short because I'm running out of time, I think. Just one comment, that's a Turkish-speaking community. All of these people in this community were mainly speaking Turkish. So you see the kinds of like information and the richness that we can in this data, which allows us to draw like in so many directions, so many conclusions. And it was just one excerpt that I showed you. And what I would like you to take away again is you can do you could do the same thing up to a certain point with Twitter's API. Now it's closed. But there are other social media platforms, smaller ones, where you can attempt similar things. Social media is important for research. It is really a driver. It enables so much. The group I'm working in is also looking into disaster management and epidemiology through social media. Think about people tweeting, I am sick, or think about people tweeting, I am in a hurricane right now. This all can be covered through social media data research. This is something that I really want to kind of pay attention on because the situation is currently a bit bad. That's it from my side. If you have research ideas, if you want to discuss, please contact me. I would be more than happy to collaborate. Actually, on PyCon Berlin, someone approached me afterwards and had exchanged some ideas for a research project, which I found super cool. Go ahead. I'm open for your questions now.
Thank you for the talk. And we have some questions. The first, how many people of the ones you crowd had a useless location? For example, a website link or a phrase like the word or earth?
A very good point. I think I didn't mention it, right? Fake locations is a huge thing. So first thing, let me show if I have it in my appendix slides. Yes, I do. I think I lost 50% because they didn't provide a location at all, and a certain amount of percent because the location reference wasn't geocodable, which means nominatim couldn't make sense out of the textual description. This then refers most likely to things like, you know, I'm living in the world or in the universe, something like that. It's a problem. This is something I needed to filter in the data, yeah.
Remap with communities plotted. If you loosened the density needed for a community, would maybe Switzerland, Germany, and Austria form a big community?
The density, sorry? If you loosen the density
needed for a community.
I didn't try, I think, if I remember correctly. So I think the modularity scores of these communities were quite high. So I trusted that these results were, I say, reliable. The other thing that I would like to think here is why these results I think are strong is, so Austrian communities did spread into German communities, but not vice versa. And that's interesting because Germany is way larger than Austria, right? Austria has the size, population-wise, and I think area-wise not, but population size as Bavaria. So the influence could have been way stronger, but it's a good point. I didn't try it out. Yeah.
Do you have any advice for geocoding a large number of locations in an efficient way?
Yes, you can. You can, of course, set up several of these agents. That's not a problem. I think it's just, as a shared resource, it's important to stay fair, I would say. Just don't be greedy. It's okay. Like, lots of people do it. The service is open for free for all of us. You can set up 100 agents if you want. Just make sure they're using a different IP address. I don't know. But it's not fair.
In the semantic analysis, anything interesting with quoted tweets, especially tweets from one community quoted into another community?
With quote, I guess it's meant mentioning or reply tweets, or what does it mean?
One moment.
Sorry.
So on Twitter, you can take a tweet, and if you link it, it will be included in the...
As a reply, right?
Not quite, well, not replying to the tweet in the comments. It's it basically appears as if it's a picture inside the tweet.
I didn't look into that. So what I try to do is mentioned networks, which is a bit different. So if someone mentions someone on Twitter, but this I didn't look into. Can't answer. Yeah.
Okay. Do you have a question?
Yes. Modularity analysis has the granularity problem, right? When you're doing modularity as a community detection algorithm, you have the problem of granularity and the modularity scores. Yeah, how did you, like, why did you choose that as your community detection algorithm?
It's a really good question.
Because, like, you have small states or, like, smaller states that could get, like, included into bigger ones, and you have some approaches to, like, go around the granularity problem, but they are not really good. And like better methods like spectral clustering, they are not really
Yeah. Yeah. It's a very good point. So what I also tried out is Leiden algorithm. I don't know if you know that. It just didn't. So Leiden also optimized by modularity, but it didn't return the same height in modularity scores again. I tried out several of them. Louvain turned out, which I used to be the one that was most scalable and most usable. And of course, there are several ways which you can do, which also offers room for different interpretation. I didn't look too deep into that, to be honest. Say again, sorry?
You got like really big hubs in social networks that
Mm-hmm.
are like influencers or people that are have like a huge amount of connections, like they are towards them, but they don't really go out. I usually try to cut them out.
Yeah, absolutely. So
like, I think for this kind of communities, it's better.
Please keep it concise.
Yeah. So I think the comment is completely valid. So we have a problem with the structure of the network. If you think about the network that I showed you, the density in the network overall is kind of low, which is due to the crawling strategy. If you think about the way that we crawl, we start with start users, followers, and followers, which means we end with lots of leaf nodes where we never retrieve the followers of that. And it's a problem. It's a limitation of the study, certainly. I still find that I trust the results that I did because we checked that a lot. Like for a sense of validity, in the sense of checking the communities, what they talk about. We checked for the users that we identified as important. So the results seemed in a manual probe absolutely valid. But of course, they need and can be improved with terms of the algorithms applied and with terms of crawling strategy, as I said, definitely. Sure.
All right, we finished the time. Thank you very much again for the talk.